the folder which we had shared last time, which we were all using in case we don't have it. And so in that folder at the top level, there is a document called like GenAI training resources doc basically, right? Docket. So that is where we have tried to compile, most of the resources which we thought, on different topics, which we thought you could go through a little later and try, and a mix of things, some blogs to read, a few videos, uh, some links to some of the GitHub tutorials on some of the topics and things like that. So that we felt, I think, if you want to kind of pursue this and try a few things, then those might be the useful resources.
Can you share that link again on chat?
Sure. I mean, I did, but I'll do again. No problem.
Hey, hi, Samir. This is Sunil here.
Hello, Sunil.
Hey,
Welcome.
Samir, I'll be back in 3-4 minutes. You can
Yes.
start when people are ready. Okay. Please.
Yeah, sure. Because anyways, I think we'll just give a couple of minutes more, or maybe 1 or 2 minutes more. So yeah, you can join in. Okay. So Yashwant, I have shared the link again.
Yeah.
Just make sure.
So this time I have opened the link in Chrome itself. Last time I had
Chrome
opened
itself. Okay. Yeah. Right. And make sure you are logged into your Google and all that. I think things should work.
Yeah. Let me see.
Just check it out. So those who have just joined in last minute or so, I've shared the link again, where we have our exercises, jump links to our exercises, and there is also a GenAI training resources doc. So let me now share my screen. Yeah, so my screen is visible, right?
Yes.
Okay, yeah, perfect, yeah. Okay, so I was just talking about this particular document, in case you have not seen. So this document is where we have compiled a list of things which you can go through on various topics. Some could be a little bit deeper, and some could be at a higher level and all that. So just check those out later on. And for the young guys who want to kind of go through some certification, there are certain links, general reading material, links to certain books, which could be pretty useful later on, and on various things. So few tutorials, ready-made tutorials, which also you can look at later on if you want to pursue further, things like that. And the topic for today, right? Agentic AI and fine tuning. So there are also links on those which you can look at. And we'll probably folder will remain shared. We'll probably keep updating these links. Okay, so yeah, I think we are ready to get started. Yeah. Okay, so what we'll do is, I think before I proceed further, so what we want to do is we want to do a couple of things. So I'll first we'll just walk through where we are, in terms of these 2 days. It's been like a week now since we connected, and we'll do that. And also on the RAG, right? We will. Prasad would also take us through just a very quick, rapid fire, recap. And I think Yashwant gave us a good suggestion that, to make the concept very clear, we should have a little bit more diagrammatic way of, representing things. So Prasad will take us through that. But before that, let's just do a quick recap. So where are we and why we are going through this kind of syllabus, right? So first is a very, very general introduction to GenAI LLMs, which we looked at what exists in the real world, which are these popular LLMs, and what is a very, very high-level concept about these LLMs, what are they supposed to do, and we simply define them as, engines which generate the next token. I mean, this is like a very, very, raw, crude, one-liner description of the LLMs, but they obviously do many more things. And then we started doing some hands-on, with the prompts with the LLMs directly. Then we said, okay, now if I want to integrate the LLMs in my application, my own application, how should I do it? So we saw one demo from Prasad, and then we did a lot of hands-on. I had also parked one hands-on for you. I don't know whether you got a chance to play with any of those, multimodal audio input and all that. but do go and play with them if you are not. So that basically was mainly introductions of the APIs which are there, and then it was also about capabilities of the LLM. Like you could see that if you give it a good example, then of how the output should be of a JSON, then it learns from that and quickly, and then that's called on the flight learning, and it can learn and generate outputs like that and things like that. So we saw a few examples of the capabilities, how to leverage them, streaming, non-streaming, etc. Okay. There is an alternative which we didn't go into because that's a little bit more hands-on centric. Like how do you develop a full application? So Prasad gave a glimpse of the application, but that's it'll be a little bit overkilling. And then ignore the tools part. And then we went to the RAG, right? And then we looked at some basic concepts of how, if you have unstructured data, typically, how do you ingest it? How do you break it down? How do you create chunks out of that? You need to create embeddings because that's where the machine learning algorithm will work. They don't understand text, they understand numbers, and that's what we looked at. And where do you store them? You store them in vector databases. So we saw example of Pinecone. And this also had kind of, done a run through. I'm not sure if anybody was able to run it, or we'll go into that. Did anybody face problems? So we'll go into that a little later. And that was about the RAG. Like you retrieve the narrowed down information from a vast knowledge base, and then you provide that to the LLM along with the QA question, and then you get the output. So this was the idea, right, of how RAG works. So far, any questions? But obviously on the RAG, I would like also Prasad to kind of chime in. But before that, any general questions so far, whatever we have done, or should we cover something more, something less, whatever, right? So that we are very, and today I feel with agentic and fine-tuning is a very, very difficult topic, frankly speaking. So again, I'll be running it in a demo mode. You will have the exercise with you. You can also run along, but I would say maybe watch or maybe just run along. But it's going to take some time. It's a little bit heavy topic, but agentic will be doing a lot of hands-on also. So there are a lot of concepts and a lot of hands-on there. But we feel maybe by 1:30 we should be done. So we might have some time, and hence, if you have any general questions, we should be able to address them. That's what we feel. So just opening it up, any generic questions, any doubts that you have before I hand it over to Prasad?
I have few queries, but I mean, we can take it later. It's not, I don't want to take time right now.
Yeah, okay. Yeah, sure. I mean, do remind us.
Yeah,
so
yes.
that we address your queries. That is important.
Yeah, we can take it at the end of the session also, where we can.
Also.
Yeah.
Yes.
So I think Samir, shall we start? I think probably.
Yeah, then let's start. Yeah, because 10:08.
Yeah.
You start with the recap of.
Sure. Okay, so let me share my screen. Is it visible?
Yes, we can see.
Yes.
Yeah.
Yes.
Okay. So good morning to all. Welcome you back to our second session or a second day of GenAI and agents. So what today I'm going to do is very quickly for first 10-15 minutes, based on the feedback which we have received, is we'll simply quickly revise the concept of RAG with an architectural diagram, so that the things will be more clear, like how the architecture may look like for a typical RAG kind of implementation, or whatever the example which we have seen, the PDF one, that also we can map to that. And then we can have some question answer session on RAG. And then we'll start with the actual today's agenda, which is the agents part. So let me start with the RAG part. Now, I'm not going to cover again what RAG is all about, just quickly going to go through the architecture and the basic why part of why one needs a RAG. So let's take a simple example. Let's say there is an enterprise or a company who is in a repairing or servicing of different smartphones. So of different companies, maybe Samsung, Apple, or other big giants. who are selling their smartphones, but let's assume that they have outsourced their servicing or repair, or maybe even a portal which is running on this repairing services to an outside company. Now, suppose this company decides to implement a chatbot to answer customer queries about repairing of their phones. So the phones could be of different models from Apple or maybe Samsung, etc. Now, all those service PDF of those phones, then the past repairing knowledge, the past policies of the different companies, or other current policies of different companies. So maybe a refund policy, repairing policy, etc. Now, all that data is an enterprise or a proprietary data of that company. So that is something which is not available to a generic LLM like OpenAI or maybe Gemini. So they are primarily trained on the data which is available on the internet in a public domain. But this data is a proprietary data and which is available only inside. Now, what if customer asks questions which needs answers which are based on these PDFs, or maybe a knowledge base which is available on a local portal, or maybe even your local document management system, etc. So in that case, naturally our LLM will not be able to generate specific answers, because the knowledge which is needed to answer those questions, they are part of this internal data of the company and not part of the generic training data which is used to train these LLMs. So that's the main challenge. So to answer customer queries effectively based on the whatever input query, we need to retrieve the relevant context. And from where we need to retrieve? So we need to retrieve it from the raw data of the company, so which could be our PDF, knowledge base, etc. Then refer to that, generate a context, and then give it to our LLM for actual generation of the response. So this is an additional processing which is needed when the knowledge is not available as a part of core LLM training data. So that's the challenge. So you have an enterprise who has their proprietary data, which they want to use it for generation of a response, but they are using an LLM which is a generic LLM, which is like OpenAI or Gemini. So they are not going to answer based on their specific data. So this is the real challenge. So somehow, based on whatever the query which is going to come inside, our chatbot should be intelligent enough to go through some internal store, pick up the relevant context, and then give it to LLM to generate response. So that's the challenge, and that's where this RAG comes into picture. So that's the basic what I can say, a background of RAG or a need of RAG. Now let's see a typical architecture of how RAG is implemented. Now there are two aspects of RAG. First aspect is, now this RAG, like as we have seen in our previous slide, it needs proprietary data. So it is part of your raw data of the company. Now, whenever a chatbot is receiving a question, the chatbot max has 2 or 3 seconds to respond, even less than that. If your chatbot is going to take good amount of time to respond, then your end customer is not going to be very happy about it. So somewhere based on the input which you have received, you should be able to understand what really customer is interested in. And then based on that, you should be able to go to your company data, retrieve it, and then give it for generation. Now, suppose your company data is huge. So it could be maybe large number of documents or maybe databases and so on and so forth. So it is not possible to run your query against that raw data, because your retrieval may not be efficient enough. It may not get the right documents. So it will not have right context and so on and so forth. So that's why we need something called as pre-processing. Now this pre-processing is very similar to the concept which is there in data warehouses or data marts. So in case of data warehouse and data marts, what we have is we have a company's large transactional data, and we never run our data mart or data warehouse queries directly on that transactional data. So what we do, we actually pre-process all possible warehouse data and keep it in a separate database. And all our data warehouse queries, they run on that particular data warehouse database. So that makes the retrieval very fast, and you don't have to do those calculations. In a very similar manner, in this case, in case of pre-processing of RAG, what companies do or what architects do, they will took all that raw data and then they will process it. And after processing that data, they will store that data into a store called as vector database. So this is where what this architectural part is. So you ingest your data, you pre-process it. Now this is your huge enterprise data, and then you store it in an efficient manner in your vector database. So when you store into a vector database, what vector database is going to give you an advantage is whenever there is a retrieval query, the retrieval from a vector database is going to be much relevant and much faster as compared to retrieval from the actual raw data. So this is like a separate process which one has to keep on running. So you ingest the data whenever a data gets updated or new data comes, you have to process it and store it into vector database. And this vector database, it has its own indexes and it's different ways of storing the information and so on and so forth. So we don't have to go to too much technical details of that. But then key thing which you have to remember is this is something much more faster, efficient as far as the retrieval is concerned. So that's the preprocessor part of our RAG architecture. Now let's see the retriever, or that's the main part. Now on the left hand side, you can see there is a user interface. So what user interface is going to do is user interface is going to give some input. Is maybe it could be a query which I have given it to my chatbot. Then that query goes to the retriever. Now suppose here retriever now based on that query, now that retriever needs to fetch the context from the context database. So this retriever based on the input query, it will go to the vector database and fetch the necessary context. So this is how, based on my query, I have retrieved the different chunkings or different parts of the data which are most relevant or more to my query. So that's how this context is retrieved. And this could be a much smaller part as compared to the large reference data which is there in my vector database. Once you have this context, then it passes that context to your LLM. So now this is where our prompt execution takes place. So your prompt execution, it has a prompt and it has a context which is very relevant to this input part. Then LLM processes it and then generates a response which is very specific to what user has asked. So to relate to our PDF example which we gave, so in case of that PDF was related with government of Maharashtra's tourism document. So now that particular document, mostly it is an internal document and it is not, our LLMs are not trained on that very specific document. Now suppose if we want to fire queries or get the context from that particular document, so what you need to do first is take that particular document, do a pre-processing and store that pre-processed data into this vector database. So that's what we did when we read that PDF document and then pre-processed it and kept it into this vector database. So all the chunks which were processed and they were part of this data pre-processing part. And then an index got created, and now we have a wonderful index for that particular PDF, so that the retrieval can become much faster and more relevant. And then next time, whenever the query comes inside, now based on that query, it will pick up the corresponding context from the database. So let's say I think we asked question about what are the best seaside hotels in Mumbai. So whatever the seaside hotel Mumbai references were there in that particular PDF, they were already processed and stored into this vector database. So based on this query, it retrieved those data parts or maybe the chunks, and then those chunks were used to build the context, and then we pass that context to our LLM generator. So that's how we ensured that whenever a user was asking anything about hotels, let's say seaside hotels, it used the data which was part of the PDF which we supplied. Now in the demo, because it was a simple demo, we had only one PDF. But maybe in a real life, there may be thousands of PDF, there may be databases, there may be even multimodal input. So there may be even images. So all that thing, we have to process it and put it into vector database so that generation of context is easier. So this is the need of RAG. And this RAG is now, I think, most of the GenAI projects where they need a specific data, which is the proprietary one available inside enterprise, they need to use one form of the other of this RAG architecture. So this is quick revision of RAG part. So which we felt that I think it is needed to go through it once from end to end. So with this now, let me just stop here to see if there are any specific questions where me and Samir can answer about this RAG part. So we can open for questions if any questions are there.
Prasad, this is Sunil here.
Yes,
do we have a situation or need where we will need a kind of a hybrid implementation where there is a enterprise knowledge is required plus a open source domain knowledge is also required? Is there a situation where we can implement hybrid architecture?
Yeah, see, actually, to answer your question, when you say open, if that particular documents are not already trained or are not already used to train your LLM, let's say OpenAI or maybe Gemini, then they are as almost same as your internal documents. So you need to process those documents and keep into your vector DBs. So actually, it is something which is, I think, if you want to make it, let's say, very simple part. If you have documents which are not likely to be part of the pre-process data when the actual LLM was trained. So maybe when OpenAI trained their LLM or maybe when Google trained their LLM. So anything outside that, you need to ingest it into your vector DB. So it could be your enterprise data, it could be other documents which may be open source, but may not be part of the LLM. So that's the call which we have to take while implementing. Plus, at the same time, the architectures are never that straightforward or simple. Like sometimes you may process the query without even using vector database. So at the end of the day, what is important is that you have to retrieve the most important part which is needed to answer that query. So either you can take it for vector database or maybe even some other sources as well. Yeah.
Okay, got it.
In fact, some part of the answer you will get it when we go into agentic and look at something called as tools, which expand this RAG way beyond the structured document. But maybe till that you can hold your question.
Okay, thanks. Got it. I'll hold it. Thanks.
But that's a very important point, Sunil, because this is very.
Yeah, so I was thinking aloud. For example, you were referring to say mobile kind of data. So I don't know what exactly context was. Suppose if it is a mobile repairing or whether this problem falls in warranty or not, this kind of thing. So there could be some generic solution available for that problem in open domain already, which could
even
be very easy
over the internet, right? Or based
over
on
the
the
internet,
learnings or over the internet. These two things are different, by the way. What model has learned without looking at the current internet, that is one knowledge. And then there is wide knowledge in the internet, right? Whether right or wrong. Now that is the problem, but whether right or wrong, that knowledge is also there. And if you make a decision to utilize both the knowledges, right? What model has learned or what is out there outside of your private knowledge base, you can surely utilize it. So how you write prompt, maybe a single prompt, or how you divide and conquer, right? So you gather information through multiple paths and make a decision. Okay. All these options are with you basically, and that's where the architecture of your solution really is in your hand. This is just kind of one pattern, but you would have many hundreds of patterns which will come in basically. You will decide how to prioritize, whether I should give weights, whether I should score, whether I should use LLM to score and decide, oh, is this right, wrong, evaluate. There are many things which are emerging, which are way beyond scope of our discussion, but you're absolutely right. The real architectures are way more complex than this, absolutely.
In fact, when you push 10,000 documents into a database, like there is a good possibility that your query will get confused, like which is the most important one. So you have to be also
we might get multiple answer for that query. That's what.
Which may not be correct actually, and also So I think that's why we say that human intelligence is still dominating everywhere, because that's what we have seen. It's fine, it will generate, but you want to, at the end of the day, you will need immense intelligence to architect that. So it's not still that easy, but definitely it solves a lot of challenges. And this is a pattern which we can build our architecture on the top of that.
Ranjana ma'am has one more question on image databases, that if my information is on images, how does it work? So that goes into a little bit of a different domain, right? pre-GenAI, it was like a CV, computer vision domain. And now, if you decide to use LLMs, right? LLMs, which are multimodal LLMs, now we are looking today, whatever so far we looked at, mostly the text going in, text coming out. But your multimodal LLMs, which basically they have specific API, like a vision API, right? So if you use those APIs, those vision APIs can take images. And we did one exercise of that, right? That you can take, what was that? Saxophones and guitar and infer, and then correlate with other information that you have. Or you can do pre-processing through traditional techniques, OCR, right? So object character recognition and all that. So you can do that. There are very strong, like for 20 years, this field of CV and OCR has evolved, right? So if you take any of these clouds, whether it's Google or Azure and all that, they have fantastic OCR solutions, which in my consulting, exercise we are actually already using, which can extract a lot of information from within images. For example, your image is not just image, but the image has also textual information and correlations. It can actually extract that. And that information also you can use. So there are multiple solutions there that you can do OCR, and you can use LLM vision APIs to achieve whatever you want to do. It's pretty powerful. Yeah.
Or maybe even some of the solutions could be as simple as a part of pre-processing. You read an image. Maybe let's assume that it's a picture. So you convert it into its textual representation, maybe what is there in an image, and then use that textual data for generation of context.
Yeah. So that I think where is your ingestion, right? Data ingestion, data processing. So we actually normally do that. So we put OCR first and extract as much information as we can. Then you pass it to LLM again in between before going to vector database, which helps you generate a summary of information. So that's like a more generated metadata. And then you store that along with reference to image in your databases. So you now have a text, like Prasad said. So you can actually match the text, and if you want reference to image to be shown later on, you can do that in your retrieval pipeline. So all that is very much feasible. Okay,
I have one question. So how does it work efficiently when the real-time data is generated and the same data user is expecting to retrieve? Like real-time.
Yeah. So your path, which is the retrieval pipeline, is a real time, right? Which means I have typed something in the chat box. That use case, right? Yeah.
Yes.
Yeah, exactly. That's why it is designed. That
no, but data ingestion is also real time. If data ingestion is also
data ingestion is not real time. Sorry, I mean data ingestion typically is behind the scene. Yeah, behind the scene, because it takes a little bit more time, because the pipeline is little bit it takes time. It's like not like I mean. Now with the more powerful LLMs and all that, things are fine. But if you have, typically organizations have hundreds of documents coming in, right? And that's why it's not really real time. It's a batch process, backend process, or scheduled process, things like that. Most of the times that way. So it is your retrieval pipeline is the real time, typically in the organization.
And again, now was like we used to implement for data warehouses. Like let's say an architect can have one depending upon the query. If it you can make that decision call whether you want to go to the vector database or go to the transactional database where the most fresh data is there and generate the query or answer from that. So that is again an architectural decision. But as far as the standard pattern is concerned, it is not expected to be real time. So it will process it, keep it, and then it will be used for generation. Any other queries?
In less 10:30, so maybe Prasad, let's start with agent PPT from your side.
Okay. Yes. Okay, so now let's start with something which is a lot of people are talking about nowadays, which is AI agents. Now, just first disclaimer, which I just wanted to highlight is as far as agents and AI agents and everything, or agentic AI agent workflows, you will find so many different terms and so many different definitions of these parts. So you have to take all those definitions with so there are no hard and fast definition of what an AI agent is. It depends upon what you are referring to. So what OpenAI may say a little bit different thing, maybe a different framework, it may say a little bit different thing. But at the end of the day, what we have to remember is the basic architectural idea which defines what these agents are all about. So maybe there will be some little differences about what definitions you are going to see here and maybe what you will find. And the main reason is that it is continuously evolving and different companies are coming up with their different ideas, innovations, and so on and so forth. So with this, let's start with what AI agents are. But before that, let's understand what an important limitation of LLM is. Now, first thing is LLMs have access to only data on which they are trained on. So this is something which we also learned when we were understanding the RAG part of it. So it knows, as far as the next token generation is concerned, it knows very well based on whatever it has learned. So all the documents which were given to the LLM at the time of training. So that's where LLM can answer. It doesn't have access to proprietary information. Maybe as we are saying, an enterprise internal portal. Now that is something which is not available to LLM. So LLM will not be able to generate. Now same thing, we saw same challenge in case of RAG as well. Plus LLM, they don't have access to current or real-time information. For example, current weather in Pune. Now that's where a little answer, where the last query which we answered about answering about real-time information. So something may even come in this particular pattern as well. So another limitation is no access to current information. So what is the current weather in Pune? So LLM doesn't have understanding of that because it is trained on at maybe 6 months back, whatever data which was used, it is trained on that. So this is an important limitation of LLM which we have to understand. So let's park it here and then take it ahead. Okay. So now what will happen if you ask questions to LLM about real-time information or a proprietary data? Now what I want you to do is go to Gemini and then ask this question, what is the current weather in Pune? So if you can, I will also open the Gemini part and see what answer it is giving.
It also depends on the model you choose. So you'll have to choose a little bit older model.
Now you can see it has answered this question. And then so immediate response will be, oh, the LLM knows what the current weather is. But immediately if you notice the response, then you will see something Google weather, which is displayed below this diagram. So what it has really done is it has gone out based on my query. It has gone out, talked to Google weather and fetch this weather information, and which is about the current information of Pune's weather. So this data, it has answered successfully. It has not said that I don't have answer. What it has done is it has intelligently gone outside, fetched the data from some external data source and shown it here. So as an end user,
Prasad,
you will feel, yeah, sorry.
Prasad, do one more thing on the left-hand side, just to make the context clear. On the left-hand side, you have 2.5 flash. Pick out the drop-down below Gemini. Yeah. Just pick the older model. Oh, it doesn't give anymore.
It's not allowing it. Yeah.
Yeah, but if you had older models, I just want to make it clear, you would get a very different response. It will actually tell you that, I can provide you a general weather outlook, but I cannot give you accurate information, etc. If you use 1.5 and things like that. So that is also interesting to note.
Why it is not showing on the right-hand side. Ideally,
you are not logged in.
You
are not logged in. If you are logged in, it will give you those. OpenAI is very, very close nowadays. It's not open anymore.
In all in all interfaces today, including Perplexity, Gemini, or Copilot, they have come over this barrier. They have now able to fetch at least known sources of information.
Yeah, and we'll explain the reason for that. We shall come under the tools, basically, topic, which is where Prasad is also getting at.
For some reason, it is not showing 7, but at least what you can change.
I think I'll show in the Play Store. I'll show basically later on, basically.
Yeah. Then here, now I just wanted to show that it is going outside. So maybe let me clean it up. Just observe it very carefully. It comes and goes. So let me paste it here. Now, let me send this query. You can see searching the web, and then it has generated that. So what it has really done is this is not generated. The information has not come from the LLM. The information came, or the context came from the web, and it used this data to generate this response. So this is what I wanted to highlight. So LLM is not trained on naturally trained on current Pune's data. So it understood what that query was, went outside, fetched that data, and used that context to generate this response, actually. So this is what I wanted to show it here. So you can run this query and even try it out on your screens as well. And then that's where these new tools like even Perplexity, they came up with this idea first. So they integrated search and LLM very nicely. But now you can see almost all LLM providers are doing that. In fact, Google search is already had something called as the AI mode. So it does much more than a typical search. So let's go back. So typically, if you ask questions about the real-time data or maybe or proprietary data, naturally LLM will not be able to answer by itself. So somebody has to go outside, fetch that data, and then use it in the context to generate the response. Very similar to our RAG architecture. And that's where the concept called as tools comes into picture. So what is a tool? A tool is nothing but a function, component, or in a simpler word, an external resource. What it does is that is used by the model to perform some specific task. So the task could be searching the web, generating images, executing code, accessing data. There are many tools are available. So tool is something like it's an external API or external function which is available to your LLM. So if your LLM is not able to get the right context or not able to generate, then it can take help of these tools to perform the task. So it's very similar to, let's say, a carpenter who is going to use different tools. So carpenter may be expert, but unless and until that carpenter has specific tools, you can't really get the best out of it. So very similar to that. So LLM has everything as far as the training is concerned, but whenever it needs some very specific information, it has to go with this concept called as tools. So it is nothing but calling some external function or maybe referring to an external source. So what is the key advantage of tools or key capability of tool is you can extend the capability of LLMs. So tools allow LLMs to perform tasks which are beyond their training data, which increases their versatility. Now, as we have seen, get the Pune's weather, or I may even fire a query, what are the current cheapest flight tickets available from Mumbai to London? So naturally, those cheap flight tickets information is not going to be available in the LLM. So that's where LLM has to go outside and then get data into context and generate the response. But then as a user, you don't have to worry about from where it has got. So in the pre-days, like maybe 3.5 turbo version of LLM in OpenAI, it used to simply raise their hand, say, sorry, I don't have access to data. But now with the introduction of tools, all the latest models, whether it's a 2.5 Gemini or OpenAI 4.0, so there they are able to call these tools and get the relevant data.
So I have one question.
Yeah, sorry.
So these capabilities of having tools in place to access any information outside, that would mean any query which is coming in, the LLM should first figure out whether this query is handled by my trained data or not. And if not, then it will choose one of the tools to get the information, correct?
Yeah, actually it is little different. So we'll cover it in the next slide.
Okay,
yeah.
Okay.
So there is a component which is in between. So more like a something where you need to register these tools, because somebody has to say has to inform the in between framework is look like these are the tools available which you can use it to answer queries if needed, kind of. So again, an LLM will be used to figure it out. Is for this kind of query, are there any tools available? And then the framework will use that tool. So it's like a two-step call. So I will cover it in the next slide.
Plus it will have to figure out, right, whether that data, whether LLM itself is trained on that data or not, and then only it will go for tool.
Absolutely. So that's where the first query will be. So whenever the first query will go, so LLM will respond back saying that it doesn't have necessary information. But then if there are any tools available, this tool can be used to get that data. So if it finds that tool, then it will answer. If it doesn't find that tool, then it will simply say that, sorry, I'm not able to answer the question.
Okay.
Yeah. So a sort of a framework in between will do that job actually. So that I will show it in the next slide. Yeah. Then it can access real-time data like the current, the integrate will use current dynamic information like current flight tickets or weather and so on and so forth. And also can perform very precise tasks which are not possible for LLM to do, such as doing mathematics. So maybe a calculator. So if you give a calculation function, the best is an external API which is best expert in doing a mathematical calculation and return it back, or maybe a parsing of file and so on and so forth. So all those things are very precise external tasks which are done by an expert, which or maybe an external resource which is expert in doing those tasks. And that's where this concept of tool comes into picture. So let's see how really the whole thing works. Now here on the top, we can see there is a query. What's the weather in Pune right now? Now, what really happens is whenever the user initiates the interaction by providing a prompt, like what's the weather in Pune? So first LLM detects that it is not able to answer that question because it doesn't have the current information. So what it does is basically it generates a response by saying that it's not able to answer the question, but it also identifies the necessity of a tool which can get the information back. Now, if you have registered tools or maybe your frameworks which are using it, let's say, for example, if I'm using Gemini ka chatbot, or if I'm using ChatGPT, the ChatGPT inside, they have already registered your default tools. Maybe it could be weather or whatever the publicly available. So in that case, whenever LLM will detect a tool is needed, your framework, it will identify what kind of tool is needed to call. But LLM itself will not make that call. It will simply say that, hey, I'm not able to answer, and it will return back the response to the intermediary, which is the framework, which is hidden from end user. And that framework will actually pick up the necessary tool and then make a call to an API or function which is exposed by that tool. So in case of our query, which is, let's say, weather in Pune, it may make a call to Google weather tool, or it may even search. Even Google search is also available as an API. And in fact, there are other search providers also, like DuckDuckGo has made their API available for search. You can take that data out and then use it to generate the response back. So what tool does? It returns the result. It processes the request and returns the result. So in this case, it will return the Pune's weather. And then LLM will integrate the tool's result to formulate the final response. So for this, you can see at least there are minimum 2 interactions which are happening with LLM. In case of first interaction, LLM understands or detects, hey, I'm not able to answer, and then there is a necessity to use a tool. In that case, if a suitable tool is available, then framework will make a call to that tool, get that data, and then with that data and the response, it again goes back to LLM to generate the final response. So at least 2 steps are needed. And that's why all such queries which requires more information other than training data may need more than one calls to the LLMs. So in fact, in case of ChatGPT and all that, whenever we are making a call, inside that it may be making multiple calls as well. In fact, if you have a dev version or a studio version of that, then you can actually see a log where how many calls it is making in the background and see the complexities which is involved. So this is the necessity of tool. Now we are not going to actually independently use tool in our demos, but we are going to use this tool part as a part of our agent demo, because agents are nothing but the next level of these tools, because agents are going to use these tools very extensively in performing their work. So till these two slides, are there any queries about the basic need or concept of tool?
Hi, this is Kalpa.
Yeah.
How this database of tools, right? How would the framework or the LLM identify? I mean, where does information come from that this particular tool should be accessed?
Yeah. See, there are two things there. First is already there are the intelligent apps like ChatGPT. Now, ChatGPT is an app. So this ChatGPT app already has a registry of tools inside that, or a Gemini framework already has a registry of tools. So so all the tools which are used for processing majority of the responses, they are already registered inside their registry. So that's how they are able to detect. But there are always going to be tools which may not be part of that. So those tools needs to be registered in your while you are implementing this into your program, and that's what we are going to look at when we are actually going to execute our agent code. In fact, agents are in case of agents, we need to tell the agents, okay, here are the tools which you can use if for returning your response. So we'll actually see how to register that. In case of end user products like ChatGPT, this is already being done for us. So that's why we are not able to understand how it is working. But when we are actually going to code in next 10-15 minutes, then we will be able to actually see how to refer to a tool, how to register it into our registry, or how even framework will be able to identify the right tool. So that will cover it in just next 10 minutes.
Yeah, just to add to that, I think it's a very good question, because typically, Kalpa, if you think about tool, that's a fancy name. Our age-old name. So basically, you have some processing logic somewhere, correct? And you have some private databases and all that. So think of those in traditional terms as services or components. And what do they expose? APIs, right? So essentially, you are using the tools to reach out to some APIs, which are outside APIs, right? Whether those are your own internal applications or whether those are SaaS model-based hosted applications on cloud somewhere, that's a different thing, right? But essentially, you are trying to communicate with some external, existing logic systems, databases, whatnot, using APIs. So your tools typically encapsulate that, or they could be typically, so typically, if you imagine this over LLM layer you are building, but you already have processing logic with you, correct? And you want to consume that processing logic. What would you do? You would expose APIs, and that's how you basically integrate. And that's why LLMs are not aware of that. So you have to make them aware of it by providing a metadata, basically, about the tools, right? So the tool, when you register, tool has to declare itself saying that what it is capable of. So there is information about it, and we'll see about that. And what parameters it is taking in a textual fashion, right? Is it like what are the character types it is taking and what are the output it is giving? That's the metadata about the tool that you need to make available to LLM so that it can make call. It can make decision on the fly and it can make call. If that metadata is missing, LLM doesn't understand those tools. It cannot make the calls.
Yeah. And we'll see that how to configure it in the demo.
So Samir, it's kind of a lookup table or something. Whether I want to see, then it will come up with some tool name. And that is what we'll call. Second, the quick question.
But yeah, conceptually you can think of it like that. Yeah.
Okay. Prasad, this small query I had, you said if certain data is available or not, LLM will go and check. And if it is not available, then it will do a call to the tools. But is it the case that by looking at the question, if it is asking for current information, then by default, I know that there is nothing current available, my LLM, hence I should not even bother to do the LLM call and go for calling the tool, something like that, or it's not done that way?
Yeah, actually, mostly LLM first query will do that, because you will need your own logic first to write your own logic there. So instead of that, why not ask the LLM itself whether you are able to answer it or not? So already that capability is already built in. So that's the typically NLP problem. So either you can implement it on your own, that is definitely possible. But best way is to ask to LLM, because it has already implemented all those NLP algorithms. So just by firing a query, it will tell you whether it is in a position to do it or not. Yeah.
Typically, if you're not developing too creative an application, right? If you have a business application, then you know the answer anyways, right? That, for example, let's say insurance calculation logic. Now, can LLM do insurance calculation? Yeah, maybe. But what's its use if I'm, let's say, I say a prudential insurance and all that? I have my own logic, right? So I know that I do not want LLM to use that logic at all. Whatever it knows, I don't want it. So how do you control it? Prompt engineering. Your prompt is very, very tight. Prompt has all the guardrails to make decisions. So you are guiding LLM what to do in that. And then you could tell him to do some fallbacks, but with caution, typically. So your prompts are typically like that. Prompt says always use the tool, da, 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 da. In case you are not able to, get the right answer, you could try to answer, but with a warning or something like that. So that's prompt engineering. So you control the behavior of LLMs through prompts.
Okay, got it.
Yeah.
Okay, so let me move ahead. Now, what I want is I want you to do an exercise. So what you can do is you can post your answers to the chat. Very, very quick, should not take more than 1 minute. So now you can see what really I'm expecting you to do. So you have to schedule a follow-up meeting on 5th of August for 1 hour in Starbucks FC Road between 9 a.m. to 6 p.m. provided it is not raining. Okay, so this is required. Then pick up participants list from the last meeting. Draft send meeting request email to participants with reference to last meeting's minutes. So you can imagine this is either it could be as simple as fine, somebody has given you a problem. So how you will go about it. Now, I don't want any technical solution to that. Simple list of steps as an individual without technology, how you will go about performing this particular task. So you can start putting answers about the list of steps in the chat. Very simple, very fast. What could be the different steps?
Your ideas on how this can be achieved. And it's a multi-step thing, obviously. So there are probably need more than one tools, API, whatever you might call
so it. Even we will not go into. So let's not still go into the API part. Let's be simple English now. How you are supposed to do that, and you have this. How you will go about it as an individual. Yeah.
Prasad, you need to share the screen back because now we are seeing your chat. So
Okay, you are monitoring chat. No? Okay.
Yeah, I didn't touch it. So I think people otherwise will forget. Yeah. Perfect.
Very simple. Just try to come up with very fast. We should not take more than a minute for this. What we just need to understand or comprehend from this is not a very simple task to do. You need to think over it, refer to different sources. So now let me start giving you hints. So you need to schedule a meeting of 5th of August for around 1 hour. So now on 5th of August for 1 hour, let's assume that it is for me. So definitely you should have access to my calendar when I am free for 1 hour. So definitely an access to my calendar is needed. Then let's assume that Starbucks FC Road is always available. So let's not complicate our decision making. But between 9 a.m. to 6 p.m. And then so within 9 a.m. to 6 p.m. we have to identify a 1 hour slot. Then whatever 1 hour slot which we have identified, so we need to ensure that at that time it should not be raining. So probably again then you need to go for any weather sites, maybe AccuWeather or whatever, Google Weather, and see when it is not likely to rain. So maybe if you select 2 to 3, and if it is raining, then you can't schedule between 2 to 3. Then go for maybe 12 to 1 and so on and so forth. Then, so you have to first identify here, make that decision, 2 decisions. Then you have to pick up participant list from the last meeting. So this is typically, let's assume that it's a follow-up meeting. So you need to find out last meeting mein kon tha. So go and access from my meeting database, pick up those participants. Now, once those participants are available, they are going to be invited. But then I will like to send a request email to those participants, but with one nice draft saying that this is where in our last meeting we discussed this. These are the action points, and then whatever the action points which were there on you, then you may provide an answer and whatever is expected. So a nice email text should be generated, and then that invitation should be sent to that. So if you can see, like, this is the planning of or rather doing this task, even for an individual, let's say for a human being, is not that easy. You have to make refer to multiple sources, make those decisions, and so on, and so forth. So has everybody understood the complexity involved in answering this question? Now, typically, how one will go about it? Let's say if you are a individual person who has no support of any secretary and all that, then in that case, what we will do is we will actually go and look up your calendar and do all of those things. But some lucky people, they will have a secretary service available with them. They will simply say that this is a task, schedule it for me, and then they will forget about it. Then this secretarial service or a secretary will go through all those calendars, details, draft emails, send it, and then complete the task. So as far as that lucky individual is concerned, this is like I have given a goal and then somebody has fulfilled that goal. How it has internally that person has done that, that is none of my concern. As long as the output is there, I'm happy. So in some cases, it will be like that. In some cases, you will have to actually go through that and then coordinate these things yourself. So key thing to which we have to understand here is that there are two parts. One, definitely more than one sources to refer to. So it could be your calendar, it could be your last meeting details, it is weather. Then you have to make those intelligence decisions. So there is some sort of workflow is also involved. If this happens, then do this. If it doesn't happen, go to a different step, and so on and so forth. And maybe even go in a loop. So maybe for all tasks, you will have to go into a loop and then check it. So if you want to write a program, it's not going to be that easy. So this is what I just wanted to highlight. These are the typical problems which come across when we are actually implementing a workflow kind of a solution. So with this background, now let's get introduced to what an agent is all about. Okay. Now, all of us are familiar with this word agent or a person agent in our day-to-day life. We come across different kind of agents, maybe an RTO agent to get our license renewed, to a property agent who is going to find the right flat for us for rental, and so on and so forth. So if you see what we do in some agent cases, we actually just use them to perform with different operational tasks. So we provide them intelligence. First you do this, then do this, etc., etc. So you're actually going to give a set of steps to that agent, and agent will do it for you. So all those operational steps will be taken care of by agent. In case of some other agent who may be a more intelligent or more resourceful enough, in that kind of agent, I will simply say that, hey, my budget is whatever 50,000. I'm interested in 3-kilometer radius of Curve Road, and then on 3rd floor with lift and etc., etc. And then that agent will come into action and come up with a list of properties which are going to be within my budget. So talking with the landlords, accessing the database, everything will be done by that agent. So this agent is much more smarter than the previous agent which I mentioned. So similar to that, these agents which our GenAI is referring to also has different kind of capabilities. So with this context, let's see what one of the formal definitions says that. So what is an AI agent? So AI agent is nothing but an autonomous software system. So autonomous software system. So autonomous is a very important one. Somebody who can take decisions on its own. Powered by GenAI. So the brain of agent is GenAI, which is LLM. So agent may do different tasks, but it will always refer to LLMs as a brain. And for what purpose it is designed? It is designed to achieve specific goals through different independent actions. So autonomous should refer to LLMs and also designed to perform specific goals. Now, if I go back to my previous example of this exercise, now you can imagine I can take this problem and give it to my secretary and let secretary worry about it. So secretary is autonomous. Secretary is not going to use LLM. Secretary is going to use his or her brains. So there is going to be human intelligence there, but then going to implement set of actions and the schedule meeting for me. Exactly in the same manner, this is what an agent is going to do. But agent here is going to do your generative AI or LLM, it is going to use. So that's how it is different than our traditional workflows which we used to use, because this workflow automation was very much there even pre-LLM days. So only difference which is there is in this case, it's somebody who is autonomous and somebody who is able to even decide what steps needs to be processed. Now, in case of workflows, we have to actually paint that workflow. Take this input. If input is this, then do this, etc., etc. Now, imagine agent is intelligent enough to even come up with its own workflow and then execute it. So this is something which is one level above than whatever traditional workflows are currently doing without using LLM. So let me again go back to the definition. I think let's just understand the key points, and then we will find and we will try to relate it to different demos which we are going to look at when somebody is going to show us different demos. So it's a software system first, but it is autonomous. It will run independently, powered by GenAI. So LLM is its goal. Without LLM, it will not work. But it is designed to achieve specific goals through different independent actions. So action is very, very important. It is supposed to take action. So what action it will do? Book a ticket. What action it may do? Book a calendar request. What action it may do? Send an email. So all those three are independent actions which these agents will do on its own. And this is where the power of AI agents comes into picture. Now let's see a progress of or how these systems progress from a basic LLM integration to our autonomous agents. So last week we got introduced, so where you can see the level 1, we got introduced to basic LLM integration. So it was only limited to generation of content. So I will give something, it will generate content for me. So maybe as simple as that, it will answer my question, or maybe I will upload a photo and say that write a poem on that photo, it will do that for me, and so on and so forth. But very much limited to what I'm giving input, and it will generate content for me. Then what I have is LLM, but with tools. So in case of tools, whatever the real-time information, maybe get current weather, get my calendar. So all those things, it will refer to that external data and then use it to generate the response. So that was level 2. Level 3 is the workflow. So I have tools, I have LLM integration. Maybe and then I will write a workflow on the top of that, and it will do all my coordination processing. So it's typically like an orchestrator engine which is doing that. So like we have different orchestrators like workflows and so on and so forth. They are doing that. So that we can do that. But then on the top of that, what we have is an autonomous agent. So which is currently the best option which is available as far as the agentic AI is concerned. So you just give that agent a task or a goal, not even a task, like goal. Okay, book a calendar, book a meeting for me in Starbucks, do this things for me. And I'm expecting these things. So inside kya karne ka, all that thing this agent will decide. So that agent is absolutely autonomous. It is not dependent upon your guidance. So this is how the LLM integration is maturing. And of course, we'll be using all different stages. But then autonomous agent is the top maturity as far as the agentic parts are concerned. Now let's see. Now if we keep these autonomous agents in mind, so what are its capabilities? Very high level. Now all these capabilities we'll be able to appreciate when we go through the demos. So let's very quickly look at it and then go to the demo, because otherwise it will become too much information overload. So first is capabilities perception. It understands inputs from various sources. So whatever input you give, agent it somehow is able to understand, process the information. It may use tools, it may use LLMs, so it will perceive, it will understand. Then the next capability, it is able to reason and plan. So it will take that whatever end user wants and divide into small parts. So this division of tasks, so that capability is there. In fact, the latest models where you may have read on the internet, like reasoning models. So whenever they are performing tasks, they actually reason why they have taken this decision. So they will do step 1, step 2. Now why they have taken step 2? Because of some reason. So even that reason is also visible, how the model is actually thinking. And then whatever the steps which it is generating, whenever it breaks down, those it will get actually converted into an actual actions. So maybe whatever the action, it may fire an external APIs to perform that action. Like that API could be booking of an appointment, or it could be as simple as sending an email, or maybe referring to company's database to get the latest stock information, and so on and so forth. Then other important aspect of this agent is it has its own memory and context. So that's where the further intelligence comes into picture. So you can imagine this is, suppose agent has started working and then that agent has realized that I'm booking my meetings into Starbucks, let's say FC Road, but somehow majority of the times, let's say my Starbucks FC Road, I'm not able to book, or my master who has given me task is not very happy about it. So maybe after giving the feedback. So at that time, it may take a call. It will remember the previous interactions and may decide to book in maybe a Starbucks on Law College Road, or may even suggest that last time there was this problem. So it has add memory and context and ask the user. Or so maybe it will improve its reasoning based on the past experiences. So all those things, it has got that capability. So it can learn, it can adopt and improve over the period of time. So all these capabilities are there as a part of agents. Now people will literally promise moons once you deploy agents, but if you go to the reality, I think still it's far off, but definitely very, very promising technology. So with this part, let's go to some real life examples which are there so that you will get a little bit context and then we'll actually code. So one thing, and then we are also sharing some links here. Maybe you can later on go and have a look at that. So these are just an ideas for you to understand how typically people are using these different agents. So for one most important case study is email follow-ups. Now imagine an organization where now there are lots of salespeople. Maybe there is inside sale, outside sale, or maybe cold sales, and many times this peer they are following it on emails or maybe even on different channels. It could be on WhatsApp, LinkedIn, and so on, so forth. And then imagine a human agent who is actually going through the first email, then understanding what that email is all about, sending a response, then again following it up, then maybe personalize that email response, and so on, so forth. So in this case, there is a limit how much a human agent can do. Or here an agent is literally a human part. It is not about agentic AI what I'm referring. But same thing, you can replace it with an agent, and that agent is a software agent or a GenAI agent, and that GenAI agent can do all these tasks for you. So it will personalize your email responses. It will even optimize the timing. So last time response kab kiya tha? So generally this person responds maybe late evening. So best is to send email in the late evening. All that will be part of the memory of this particular agent. Then it will generate responses based on the past interactions and so on and so forth. And thus you can get a far better engagement with your end customers. And then this is like you can respond to practically any number of queries. With human agents, you have to keep on hiring more human agents. Here, you have to just deploy the software and maybe buy more licenses. So this is an interesting company, inboxpl.us, and then it does that. So what they have deployed this agent and you can implement in your organization. So I'm just taking these specific examples just to highlight different use cases, the practical use cases. Next one is now a lot of people say that okay, like writing contracts is a challenge, and many times there are repeats, and then most of the contracts they are similar. Let's say the contract could be maybe a property contract. Now in this case, again, if there is a human agent or maybe a lawyer, then how many contracts he or she can draft? So if you can have an agent which can do this drafting part and maybe last 10% of those contracts can be reviewed by a human agent before sending it outside. So that's how you can actually implement an agent into this legal domain, which can manage these contracts. So it can do analysis of contracts. It will identify the risk. It will see what similar contracts were there previously, what kind of negotiations were there. Now, all this data will be part of your internal organization's data. So it will use that to generate the responses. So this is how you can have a human agent who is like a lawyer who is expert in drafting contracts. So again, there are companies which are there to draft these contracts, and then you can now visit these sites later on. And then main thing what you are going to get here is productivity. But at the end of the day, definitely before even sending the contract out, definitely maybe some human input is needed just to ensure that nothing has gone wrong. But that's a risk. Depending upon what type of contract is, one can take a call. This is just an example which I'm highlighting. Again, CRM is a very big area where lots of agents are deployed. So you can automate data entries, you can give sales insights automatically. So lots of CRM tasks you can deploy agents. So wherever human agents were taking part of it, you can replace this with agents. In fact, the first and biggest casualty of jobs is going to be human agents who are working in these parts. So this HubSpot is a very famous provider of CRM, and they have a very powerful product. And I'm sure a lot of other CRM companies are also implementing in their products. So these agents are already inside these products, and they are making life easier of agents. Or there is another. This is just wanted to highlight, like some of you may have heard this company called Zapier. Now, Zapier was there for task automation. So typically, you can have your own workflows like, okay, if you receive an email, read this email, parse it, send it there. So you have to actually create a static workflow. And it has more than 700, 800 such different integrations, and you can deploy it into your organization. So now Zapier has also come up with this concept called agents, where you can have an agentic AI to provide all that automations. So in this case, you don't have to code for any agent, but you can simply deploy it inside your organization. So all those things you may come across in your day-to-day job, or maybe you are interacting with customer, and then you have to take a conscious call whether to use such kind of tools, or maybe something develop it on your own. So that's where our agentic AI development comes into picture, or building agents comes into picture. So here on the left hand side, you can see there are these three frameworks which are there. So these are three very famous frameworks which are there, where you can use to framework or tools you can use to write or develop your own agents. So here you are actually going to write code to write your agents. On the right hand side, there are certain frameworks. Now here I have not mentioned Zapier. Zapier is also on the right hand side. So here you don't have to write any code. So these are the no code frameworks. So technically you may have to write a very small piece of code, but at least most of the thing you can configure and then deploy it. So all agent functionality with LLM as a brain, either you can do coding for it or you can do without code. So with this quick background, now I will hand it over to Samir. Now we will actually now jump into the coding part. First, the framework part, what really they are, and actually we'll see how pick up one framework and write code to develop an agent and run it. So Samir, would you like to take the control?
Yeah, sure. I think what you can do is keep the PPT on for the next 3 slides, and then I
yes.
For that. So I'll just stop.
Are you sharing it or shall I share it?
And then you keep sharing. You keep sharing.
Okay, you tell me when to move ahead. Yeah.
You can move ahead. Yeah, absolutely.
Yeah.
Right. Yeah. So like Prasad said, the left three, Cruel, Langraph, and AutoGen, right? These are one of the most popular agentic frameworks which are out there, and literally every day a new framework is coming out. Okay, so there is a lot happening there. So I think what we realize is our information also gets outdated every week or every 2 weeks. But yeah, these three still are kind of leading the charts. So like Prasad said, right, there are certain expectations when you start using agents, and he explained a lot of parameters to look at it, right, in terms of its tool support, in terms of its autonomy and things like that. So whenever we look at any framework, we have to look at it from that perspective, that are they helping us, what do they provide? Do they provide the expectation that we have laid down in the earlier slides, in the theory? So if you look at CrewAI, and this is only right now concepts, that what CrewAI does is, it does give you agents, which is in the middle, but basically it allows you to build teams of these agents, and which they call this as crews, right? So you can actually have crew of agents, and when you define the crew, you can put multiple agents to work by defining a workflow across them. Okay? And I think the example that Prasad gave about scheduling a meeting, right? If you think about it, it's like a small workflow. If you make it more complicated, you want to go and book a table also, right? So there is definitely a workflow there that are the meeting slots available for everybody? If not, then find the slot within 10 to 5. Only then you go and book a table. Only then and of course, then before that, go and check the weather. If not, suggest something. And so there is a workflow, right? So you should be able to build that kind of a workflow. That is what through AI crews allow you to do that. And they allow you to define various types of collaboration between the agents, which is right there in the second one. Now, each agent, like Prasad said, has a goal or a role. So it has a role and a goal, essentially, right? So in a role, you say, who are you? So you are maybe an insurance expert, or you are maybe a weather expert, or whatever, right? And the goal is to suggest something, come up with a time slot or come up with a calculation, whatever. So that's how you define those goals. And it's pretty interesting the way GenAI does it that way. And then it executes, so it breaks down the given goal into tasks and executes the task. So those are the tasks, right? And when it executes tasks, how will it execute the tasks? By using tools. So basically, you are telling it that here are the certain APIs and each API has a purpose, right? So you figure it out now that I have given you a goal. This is your role. I have given you a goal, and here are, to execute your task, here are the tools. Go ahead and execute the task. So that is the bit of autonomy that you can give there. And then so if you don't want too much autonomy, you can give it a very static flow. And this is like a traditional workflow or the processes or activity diagrams in UML that we talk about. And you can tell it go only through these paths. That way, don't be overly ambitious and overly autonomous. Here is the flow which I'm giving you, and you can go through it. These concepts, so this is in GenAI, and if you go to the next slide, Prasad, every framework you will find these concepts. They use different terminologies. So in LangGraph, so there is a very popular framework in this thing, which is called as LangChain, right? And LangChain, is open source framework. It's like a framework of frameworks. You can talk to any tools. You can talk to you have pre-built prompts. You can talk to any LLMs. Things like that. So specifically for agentic work that we are talking about, they came up with a framework called LangGraph. And whatever I spoke in the earlier slide are already here. Instead of crew, it is called as teams. Agent is agent, and tasking is achieved through tools. So all that is there. And then they give various ways of building workflows. So I've just given some tidbits here, but I think when we go into the exercise, because we'll be doing our hands-on using LangGraph, we will see more of it. And to support all this, there are many things which are needed. Prasad talked about a state or a memory and a persistence, because without that, long for flow, you wouldn't remember what each agent is doing, right? So each agent needs a way to gather information from its tools, do the intermediate calculation, pass on that information to the next agent, things like that. So all these other things are needed over there. So that's the LangGraph, and you can go to the third one, which is also exactly similar. This work was started by Microsoft, and so actually, when 6 months back when we were working on it, it was all Autogen was a Microsoft framework, but looks like they open sourced it maybe a month or two back, and now open source community is kind of driving this under a new name called AG2, Autogen 2, basically. Same concept, agents, teams, like, we talked about crews, here are your teams, and we talked about flows through AI. Here, they're called like graph flows, which are very specific, targeted flows as to how information will flow and which agent will come into picture when and all that. And a lot of other ecosystem around it. So these are the three popular frameworks. Fourth one is Copilot, and I hope we will get time so that Prasad can give us a tidbits on Copilot, because the main difference is all these frameworks require fair amount of coding. I mean, much lesser coding than what would you do now otherwise, but they do. They are code-oriented frameworks. Very, very, you need good developers to kind of do this kind of coding. Copilot is very interesting. If you can define your problem very well, you could actually do it more like a absolutely no code or extremely low code, but mostly no code kind of a framework, fully graphically managed. So hopefully we'll get time to see a demo from Prasad. That's it, Prasad, right? This is the last slide.
Yes.
Okay. So now you can stop sharing and I'll share my screen. Just give a minute. Okay. So hope you can see my screen, and basically this link is already shared in the chat, right? So hopefully you are all here, and this is what we used last time also. So let's go to notebooks. What we are going to do now is use LangChain to understand how you build agents. Okay. So LangChain, LangGraph. LangChain, LangGraph terminology is kind of synonymous because LangGraph is a kind of a sub framework within LangChain. So you will see here M6 LangGraph agents and workflow URL. Just click on that. It should open for you a drive. Right. Hopefully everybody is here so far. Let me just confirm you're able to kind of open this up. No issues so far, right? We did this last time. So, right. So before going into this exercise, I had sent few instructions last time through mail about weather APIs. So I'm not sure that also if you can confirm. So did you receive the instruction and were you able to kind of go to weather API and sign up? Because what we need to do is sign up. Yeah, right. Sign up to this, log into it. So I had given those steps and post your login. Then you should be able to generate a key. I need to see which one did I use here. Let me find out how I logged in. Give me a second. So many logins. Okay, got it.
Prasad, if you don't mind, can you just ping the URL for accessing your notebook folder? Somehow I'm going into the next one, not for the basic. I'm going to RAG folder. I know it was there in original email.
Yeah. Same here.
And today it was put on the chat.
I have put it on the chat today. Yeah.
Okay, we'll check some again.
Just check the chat. You scroll up and you should see the link.
Okay, got it.
I don't know.
Thanks.
But yeah, anyways, I think hopefully you managed to kind of know because we'll need that key for weather API. So in case, okay, let me just do some, you have the key, right? Yeah. So if anybody who doesn't have the key, make sure you kind of log in through your email, give the password and all that, and then you should be able to generate the key. Okay. So assuming you have done that, we'll go into the first example, which is LangGraph agent. This is the bare bones first agent which we'll be playing with. Okay. So open it in your Google Colab. Somebody wants to wait or okay. Ranjana ma'am. Do you want us to wait, Ranjana ma'am? I see some message there. Let's put some message, please
The
wait.
link here because same happened with me.
What's happening?
Out the link to the Google Drive. We logged out, so we couldn't see the link to the drive. Yeah.
Okay. Okay. So let's
same
let's
is
do
I
that
think
again.
happening with her. Yeah.
Okay. Let me just share the link again.
So Samir, I got there. So we have to select HTTP or I just missed that bit.
Okay, just give me a second. I'm just pasting the link. Yeah, let's see if you are able to get to this folder. Everybody, let's do the basics first. Okay, Ranjana ma'am, let's go. I think who else had a problem? Pallavi ma'am, how about you? Okay, good. Yeah. Okay, so you are here. Okay, now click on notebooks. Okay, so last time we had done a few exercises over here, correct? So now what we're going to do is click on M6 LangGraph agents. Okay, and when you click on this URL, it should open up a drive. So let's make sure everybody sees this drive now. Okay, Kalpa is ready. Everybody, I think else is ready. Whoever has problem, please let me know so that I can solve everybody's problem here. Then after this, things will move on. Okay. Okay. So now let's move on. Done. Okay, fine. So basically, what we're going to do is LangGraph agent. That's the first one we're going to work on. So open with Google Colab. Yashwant, I hope you are also able to reach here, or Ajay and that, right?
Yes, I'm able to.
Okay, you're able to. Right. Okay, go ahead. Oh, yeah, I think my sign up has got screwed. I don't remember what login I used, but basically, this is where you are supposed to sign up, and once you sign up, it will give you an option to create a API key. Okay, so I think, and the URL is, yeah, pasted the URL here. So what we're going to do is, we already saw that if you use Google Gemini, it is aware of Google Weather, but we don't want it to use Google Weather. We want it to use our own tool, okay, and our own tool for weather APIs. And let's say this is our own tool, okay, and that's why I'm purposely changing it so that we can get an experience of tool. So this is where you go sign up and create a API key, okay, for you. Do that step if you're not done. I'll wait for 5 minutes. Or 2 minutes.
Once you sign up and then log in, it anyway automatically creates an API.
I think it creates a default one, right? Correct.
Yeah,
so if it creates, you should see the default one. Yeah. And then pick up that default key and just store it with you. So let me hold on for a minute so that. Anybody facing problems there?
No, we are good.
Okay. Nikhil, no means you have a problem or you are okay? No problem, right? Okay, good. Okay, so let's move on. So we are now in LangGraph _ agent, where we are the agent is already coded. We are going to understand how this agent is created. And as you will see, it is so simple. Because we are using frameworks, right? They make life really simple. Okay. So as always, connect. So this connect should give you a default machine on Google Cloud. So make sure you connect. Right. So you should see a green tick and a diamond disk and all that. Okay, that's always step one. Step two is that we need certain certain packages, because Google machine doesn't have by default these packages. So what are the things we are installing? We are installing LangChain, because LangGraph is a wrapper. It has some special things, but underlying it uses LangChain. So you need both the packages, okay? And LangGraph uses agents, but it internally uses LangChain framework, okay? So you need these two packages. Now we are going to use Google LLM, right? Because it gives us a free key, right? It gives us some free calls, 10 calls per minute, whatever it is, right? So we're going to use that. That's why you need a LangChain Google GenAI package also, which has special, because Google, we saw, right, last time, it has a special API. So this LangChain Google GenAI wraps up that API for us. Okay? It makes our life easier with that. Okay? Additionally, we are not going to use this. Additionally, I have also kept LangChain OpenAI in case somebody has OpenAI key. Later on, you can try OpenAI as well. Okay, that's why. Otherwise, we don't need it. Typically, when you install it, it will ask you to restart. You will just tell it to restart, and you will see that on the right-hand side, it's the machine restarts. It restarts with the package that we have installed. So now we are good to go. Okay. Now, I'm just importing a few things. We'll explain as we go ahead. We'll not spend time here. Okay. This is where you need to change the code a bit. So you're going to need two keys. Okay. So first key, which I'm calling it as a key, is nothing but a Google API key. You're already used to this. So you must be having your Google API key with you. In case you have forgotten, okay, then you need to just go to Google AI Studio, log in with your Google ID. log in with the Google ID and get API key, right? So this is how you get your Google API key. Okay. So key is your Google API key. Remove this piece of code, right? And double quote, put your key here. Okay. Same thing you have to do with the weather API key. Okay. Weather API key is nothing but the key which we got from weather API. Okay. So that also what you do is put that weather API key which you must have got just now, whatever, right here. Okay. Let me undo this. My code. So once you put the hard-coded ones, okay, we as usual we are choosing the model as Gemini 2.0 Flash and which passing the API and all that. So now we have a handle to a model. Okay. Now this is where we are going to build our agent, right? So there is a function get agent, and this is supposed to return me an agent from LangGraph. Okay. So how we build the agent? Okay. So how we build the agent? If you scroll down, the steps to create agent are very, very simple. Okay. So there is something called as create React agent, just one function. Okay. So if you go on to the web, what happened? Okay. And if you type LangGraph and paste this create underscore React agent. Where did I pick this create underscore React agent? It's here, right in the code. So I pick this up, put it here. Okay, Copilot will give you answer, but let's not go there. Let's go to langchain.com, create React agent, Langchain documentation. Okay. So this is the agent we are going to use. This is the documentation of the agent. Okay. So what it tells us is create an agent that uses React prompting. Okay, don't worry, what is React prompting? Basically, you are creating an agent directly by passing it a few things. Agent is a wrapper over LLM. Agent is nothing but LLM, right? So you need to give it a LLM, which is the model that we created, Google model. Tools, we talked about tools, right? So it needs tools, array of tools, sequence of tools, not just one tool, but multiple tools. Prompt, like we said, right? I think Sunil, you were asking, right? How do you tell the agent what to do and whether it should use its own knowledge or tools, whatever, all that. That's your prompt, right? So you have to give it a prompt to that. These are the three important things that we need. Other things are not needed. Other things are about like if the output of a tool is, let's say, textual and you want to convert it to some specific JSON format, whatever, right? You will need an output parser and stuff like that. These are advanced stuff. We don't need this. So we just give these three things. Our agent is created. That's what it tells us. That's what we're going to do. Okay. So what we are doing is, of course, there is also name. You can give it a nice name because when you print the output, you will know which agent is talking. And right now we are talking about just one agent. When you have multiple agents, this name will help. Okay. So we give it a name, we give it a model. We created the model here, right? The standard chat, Google, generative AI, Gemini, Flash 2. That's the model that we gave. Then we are giving it a tool. We'll look at it. Right now we have only one tool. So even though there is an array, I'm just giving one tool, find weather, and I'm giving it a prompt. So prompt is telling it that you are a helpful AI agent capable of finding the weather for any location in the world. You can also provide a brief description of the weather for location. I did not tell it use a tool because it's an agent. It knows that if there are tools, it should use it. Now let's look at a tool. What is it? No magic. The tool is simple. It's just a simple Python function right now, which is wrapping the calls to weather API. Okay. But important things, I think Kalpa was asking this question, right? How does it know what the tool does and all that, right? This is how it knows. Okay. This is a pattern. This is a documentation pattern, which you can call this as a function metadata. You need that. Okay. And this metadata is parsed by the LLM to figure out what the tool does. So this has to be very clear. So it says what this tool can do. It finds the weather based on the location. Okay. Based on the location and return the location, region, country, whatever, country, temperature in Celsius and condition there. It's basically telling it, I'm going to give you 1, 2, 3, 4, 5 stuff output. Okay. And based on this thing. And there is an argument, location string. So from here also it can infer, but if you follow this pattern, R colon and mention location string. And what is it? The location to find the weather for. This information is very, very important. If you don't give a good information here, LLM is going to get confused. Okay. So this tells it a string needs to come in. That string is a location because it does NLP on this, right? Location required for weather, all that, right? So it understands this. So even though we are going to type a textual stuff, it knows, LLM knows it needs to extract a location and pass it here, right? So that's our tool. So tool internally is using Python request package to make a get call, HTTP get call to weather API. Weather API needs two things: API key, which when you register you would have got it, and the location which has come in as a parameter to this function. That's it. So it goes, gets it, and it forms a JSON output. In Python, it's called a dict, not dictionary, but we know this is basically JSON. So it returns a JSON back to LLM. Okay. Any questions so far? This is the concept behind how you build a tool. This is our own tool. It depends on how you design the prompt. Yes, correct. Absolutely depends on how you design the prompt. But here, as you can see, my prompt is little bit generic. Most important thing I wanted to convey is this metadata or this documentation of your tool. This is extremely important. You mess this up and your agent is messed up after that. So this is extremely important. And when you don't get outputs that you want, you have to a lot of time inspect this. Have you made any mistake here? Why? There are chances that actually LLM or agent doesn't pick up the tool if you have multiple tools and all that. And you have to really inspect your documentation. So that documentation along with your prompt is extremely important. That's how you are guiding the agent. Right? You have set this up now. Go ahead. Any questions?
Yeah, I have a question. Is this standard syntax if you just scroll up for find weather? And so we have the state graph and then find weather. So anything that appears between these triple quotes is considered it's part of the syntax.
As a documentation.
Right?
Correct. So this is my tool, right? Essentially. So this tool anyway defines, any tool anyway defines using certain keyword, like it doesn't say XYZ, it says location, str, all that, but that's not enough. So this triple quote is a Python documentation style, basically. Python functions, classes, etc. are documented like this. So that is the style you have to use. You have to also make sure, and that style also, in that style, you have to make sure that you specifically call out the args, which means arguments to the function, right? So what the function does and the arguments to functions are also documented. So the developers who don't like documentation, they're going to face problems, essentially, right? So you have to do this. This is a documentation. Triple quote is a documentation of a Python function. So, documentation.
But Samir, this documentation is also used as a function, right? Because based on that only it is going to identify that I need to use this tool, right?
Yeah. So my def, this is a function, okay? And if you hover over it, you can see the documentation coming up in that function, right? Function definition.
Yeah.
This information is at runtime parsed by this agent, essentially, okay, to figure out what the tool is all about. That's how it goes.
Okay.
Yeah. So when we pass it as a parameter, if I hover, whatever I see is actually parsed and interpreted by LLMs to figure out what that tool, and in our case, this is a tool. Def is function, basically. I'm defining a function. Def find weather function is my tool. And that's exactly what I have passed in the tools array here, correct? I'm just passing the tools array, sequence-based tool.
So basically, the Python's documentation function is used here to hold the metadata for the function, which can be parsed by the framework to find out what the agent is all about.
Perfect. Exactly.
What the
tool is all about.
What the tool is all about. Sorry, what the tool is all about.
200 functions also here, and I'll pass them as tools. So what each function, which means what each tool in agentic terminology does, is to figure that out. Whatever you said is exactly how it's done. Exactly.
Yeah.
So that is crucial.
So there's a small question here. We are specifically asking to call this agent. So will that not be decided by LLM saying I need to call this agent because this is what that agent does or tool does?
Okay. No. Where is LLM? I mean, it's other way around. It's other way around. You are creating an agent.
Okay.
Agent internally uses LLM, which is a parameter to agent. Agent uses this LLM. The model is a LLM, right?
Okay.
Right. And to that LLM, it makes available the tools and the prompt. Okay. So it is kind of wrapping up. So if you have to do this yourself, whatever is done internally, you'll have to write maybe 100, 200 lines of code. That code is gone for you. So the framework makes it, actually, if I flatten this is one line, right? I'm creating an agent in one line. You think about it. So the agent is a wrapping code which internally makes calls to LLM, passes it the tool's metadata and the prompt and says, do your work. And then, so we will see, actually, when we see the output, I'll show you how it actually functions internally. We will see that output. But that's what it is. And okay, so that's your question. And somebody else also was asking questions. So who was that?
Yeah, that's me, but let's go ahead.
Okay,
let's see the questions.
Yeah. So just compile this.
One last question, Samir. Can you show the documentation once again, like create React agent?
Oh, okay. Video documentation once. Okay, right. So on the LangChain documentation, you will find the create React agent API documentation. This is the API, right? It's a function which they have defined. So LangChain has a package called agents.
Right. Okay.
Specifically React will not go into that and all that. And then it defines what it does and what parameters it takes and all that. It will give examples. So whatever I'm doing, you will find some example, a little bit more complicated. But there are good examples here.
Okay.
And they will also give you examples of tools and all that. How to use it. There are many examples there. Okay.
Samir, Nikhil has also.
Perfect.
Yeah, Nikhil has also asked a question: how we design prompt actually.
Yeah, I think I answered that. Yes. So I answered that by saying it is not just prompt. So combination of how you give the prompt and how you give the tool metadata, the behavior is decided. Okay. So I think we have compiled it. Now let's run and kind of see the fun. Okay. So I'm asking it, how's the weather in Pune? I think this is something that we were trying, right, on Google Gemini and all that. But Gemini was using Google Weather and all that. But this time we are not using Google Weather. We are using our own weather APIs, free, whatever that, weather API and all that. So what happened is, so how we go about this is, you create a textual message, you wrap it up in something called as human message. So this is LangChain now. So LangChain gives you two types of messages, human message and AI message. So AI message is generated by AI, human message is generated by humans, right? So you typically, when you call the agents, you actually pass it the human message. Okay, so here what I'm doing is I'm getting get agent. I'm basically, whatever this agent I have created, you get the agent. You build the messages to be sent to the agent in a certain way in an array and all that, which contains a human message, and you invoke. Now, invoke is a synchronous function. There is also a invoke, which is asynchronous function. So obviously, I kept it simple. So you invoke it, you get a result. Result is a bit more complicated. I have printed the result also here, and I have extracted the final output also from here. The final output says weather agent has replied back saying that weather in Pune, India is patchy rain nearby 27.3 degrees centigrade. We'll have to go and check. Now, Google might have a different value and all that. Interesting thing to look at will be how did all the communication happen internally? So let me just copy this and get a text pad here. Paste it here, because if you study this, sorry. So overall, what message flow occurred, right? So first message we know because we only gave a human message. How is the weather and all that? That is all fine, right? That message went in. Then what happened is it reached LLM. So the React agent actually reached LLM with an AI message, right? So in that AI message, this is actually the output of that AI message. So first message went in. What LLM figured out was, it said, well, you need to make a function call. Actually, you know what? LLM doesn't make a function call. LLM has no capability to actually making the function call because function is running in my machine, right? So LLM cannot reach back to your function and make call. LLM tells you, and you in this case is the framework. Which framework? LangChain framework, right? That framework. So it is telling that framework that you should make a function call, right? And which function call? Find weather function call. Make this call, send arguments. What arguments to send? Arguments to send is location Pune. So what did it do? From here, it figured out location is Pune. Okay, so it figured that out, and it also figured out it's a string and all that because it studied the metadata of the function, right? So it made that call, and then it will get back a response from that, that thing, and so that response. So that is a tool call. Okay. So LLM doesn't make a call. I mean, if you go really finer to a code level, LLM tells you to make a call. Now, we are not making a call. The framework, create React agent from LangGraph is making the call. Which call? Tool call. So if it makes a tool call, it's called tool message. So it made a call. And when it made the call, it got a response back. So this is the response. It got a JSON back with 1, 2, 3, 4, 5 stuffs coming out. So if you study our method here, you can see, right? We are returning this, right? So we are returning these 5 things. These 5 things. So it actually made this tool call. The tool call internally made a call to weather API. Weather API then, if you have the right key in place, right? This key has to be in place. So once this right key is in place, it makes the call and you get a response. And it says Pune, Maharashtra, India, temperature and condition. So this information came back to agent. What did agent do? It sent another AI message. To whom? AI message means to LLM. Which LLM? Google. And then that Google thing, it responded back. It converted this JSON output, JSON input, which it got into a string. The weather in Pune, it formulated, because LLM is so good at formulating. If you give it a data, it will formulate the message. And that is what finally we saw as a output coming in. Okay. So that's the process. So internally, as you can see, there is an exchange between the agent, I mean, you as a human, then the agent, then the model, the tool, back to agent, back to model, and the response. Okay. And that's why I said, just hold on. So once you actually go through it, you will realize what's happening internally. So that's the code which is inside the agent and this framework. So framework make your life easier, right? One step, define an agent. One step, call the agent, right? And your job is done. So they have made our life really simple. Okay, so okay. Ranjana ma'am, repeat the steps. Which steps you want?
She's facing problem for setting the API key. So right. So basically, you can just briefly go through the steps. Yeah.
Okay. Setting the API. So did you manage to sign up and get the default API key, Ranjana ma'am? And you're on mute. Yes, got it. Okay, perfect. Then how to set it up, right? So this is where you set up your Google API key, right? Google key, whatever might be there, right? And this is in double quotes. And sorry. This is where you set up your weather API key, which you must have copied, right? Got it? Okay, perfect. So once you do that, once you set it up, make sure you compile it, right? And compile stepwise. 1, 2, 3, 4, that way. And then you should get the output. So again, checking with everybody else. Everybody got the output? Pretty straightforward, but
yeah, Kalpa had some query somewhere. Kalpa,
sure.
So what we're seeing here as an output is essentially a workflow from the agent, right? Where the agent says, okay, I invoked this, I invoked the LLM, I got this response back. Correct. Now I'm going to invoke the tool and so on.
Correct. Exactly. So we are, if I hadn't printed this, you wouldn't know, right? You would just see a magic, but there is no magic. Essentially, it's a workflow. Your message to AI agent, it has no way of, agent has no way of knowing what this means. So it sends it to LLM, gets a response back. Then LLM is telling it, boss, you make a function call. And so it has to parse all this. So you need logic to parse this, dynamically make calls, right? Dynamic function calls. All that. That's a tool. That's a tool message on that, right? So that happens. Output comes in from the tool. Then go back to agent. Go back to LLM. Get back the response. All that workflow is happening internally. It becomes more and more complicated depending on your prompts and your tools. If you have multiple tools, and we will see those. We'll see that example. So it will become more complicated as we go ahead. But this is one agent, one tool. Yeah.
Yeah, and we discussed earlier that there are a lot of different agent frameworks now. So I'm assuming that not all agents will respond with the workflow. I mean, there could be configurations or differences between agents specifically with this workflow.
Yeah, you could have. Yeah, absolutely. There could be. So if your workflow is complicated, I have an example. I will come there. But right now we are starting small. Internal workflow is simple,
Yeah.
one agent, one tool and all that. Now we will go into two agents, one tool. And then finally we will land into a little bit more complicated workflow. Okay.
Yeah, thank you.
So,
Yeah,
so
right.
Samir, if we get a multiple output, for example, Pune, India, we got only one. If suppose there are two Pune in India, so will it repeat multiple time here or what will happen?
Let's try that. Let's try that, how it works. So either it will assume or it will fail, one of that. So which are common? I think in US, you have this, what? Indiana, right? There are 2-3 places, right? Or Washington, whatever. Let's see what it does. Okay, so it assumes.
Okay, Indianapolis.
Okay. Yeah, it assumes. Out of my guy.
So again, it's given by LLM. It will.
It is given by the LLM is interpreting. Whether in Washington, District of Columbia. It's assuming.
Okay.
Maybe it is picking up the first response coming in, whatever, right? Yeah. Now, how do you control it? Here, essentially, right? So you can tell it if you are unsure, please ask question. No? So prompt is your way of guiding your prompt engineers, right? Prompt engineering, exactly, yeah. Score, and if you are doubtful, make sure you ask a question. So you can convert into conversational AI, right? So it will converse back with you if it is unsure. You can do that, and that magic you have to do here. That's why prompt engineering is one of the last year it was one of the top paid role, right? That's why we are taking simple example, but exactly like where if you go there, then you will need somebody who can think logically what can happen. So all error conditions you have to think about. Tool failures, tool can fail back. If you give wrong API key, what happens? If your calls timeout, if you have quota gets so. System design, you cannot get away from system design, and this is going to fail. And of course. And this is just one agent, one tool. I mean, in our workflow in application, we'll have probably 50 agent, 200 tools, right? I mean, so yeah, and this is called agents. Well, they make your life simple because the amount of code that you have to write is so less, right? So less, whatever we are doing.
So, Samir, if you go a little scroll up.
Yeah. More.
And that statement where model chat Google generative AI.
Yeah.
That's where I'm getting error saying name not defined.
You're sure your key here is correct, right?
Yeah, last time I used from the last time. Maybe I have to create new again?
No, not really. Even if it is so, make sure. I mean, you make sure you restart. So one, if you're facing problem, you just timing, you just disconnect, connect again.
Samir, can you just maybe you can clean up and just give a very quick review of all steps that will help because there are some queries about that also.
Okay. So let's start again. Okay, so we are back. Let's connect again. So just try this, assuming your keys are all fine. This should work.
Let me try again to just see whether API key of the Google is still valid or to do it again.
Yeah, and second thing I briefly just mentioned that I think it basically asks you to kind of restart. So you have to make sure you restart.
Yeah, I did that twice.
You did that. Oh, okay, right. Yeah. This you have to do. Otherwise it messes up, gets confused.
Yeah.
So just check once whether it.
Yeah. And I have to put the keys in double apostrophe.
Double quotes. Double apostrophe. Yes, exactly. Yeah.
I'll restart and then again I will see.
Yeah, like this specifically. Whatever is your key will go here. So just repeating the steps, right? So we set up the keys. Missed the step. Ranjana ma'am, steps are clear. I mean, essentially what we are doing in the agent. In the agent, what we are doing is we are creating an agent, making sure we are telling it which LLM model to use, which tool to use, and give it instruction, give it a role. And the tool internally has to have a proper documentation on it. And tool, what it's doing it's doing a, it's doing a API call to external APIs, getting the output from that, parsing that output, because what you get back is the data, and from that data, it's picking up only few things. There are maybe more things coming in. I commented out the print data, forming a certain JSON in a certain way and returning it back. And then the agent knows that this is not the output I need to give to the human user. Human user needs a output. So it again goes back that to LLM and says, I got this JSON. Can you kind of make it like a little bit more nicer for the human to understand? And that's how when you kind of run it, then you'll get a more human readable format.
Yeah, mine has worked now.
Work now, yeah. Okay. Many times this, maybe it's a restart or something like that gets messed up. So I think just clean up and start again. I think this is the best way. Okay, working, yeah. Okay. Ranjana ma'am, steps clear or any specific step if you want, feel free to ask. Once you get the steps, the further exercises are much easier because they're just repetitive. Okay. Steps clear. Okay, that's good. Okay. So I'm just relinquishing my machine for the next one. Okay. So we are done with this. What we learned here is
Samir,
build agent.
Can we take a little break? It's 2 hours.
Okay. Okay, 12 o'clock. Okay, let's take 5-10 minutes break or something like that.
Yeah, 11:57. So
12:05. Yeah, 12:05 we can assemble back.
12:05 we can start. Yeah.
5 minutes after 12. And till then, if you want to try something, play around, do play around because that's the whole idea. Play around with this example, and then we'll start with the next one. Yeah. Kalpa, so you did play around. Okay, yeah, exactly, right. If you give it, through your prompt, you can absolutely control what output comes in, right? So yeah, okay.
Yeah, I was curious to see how much influence that documentation actually has.
Also has a lot of document, lot of influence.
Yeah.
So actually, the agent, it learns from, in fact, the other framework also. It could be part of the code or it could be part of the metadata file which one has given. So all the descriptions, whatever we are given, it simply double code learns from that.
In-flight learning.
In-flight learning, yeah.
And we will learn the hard way of training it later on, but that is a really hard way, fine-tuning as it's called. But otherwise, 95% of the time you'll be using prompt engineering, which is in-flight training. So I'll also be back, have a glass of water and back in like 1 minute. It's going on mute. Everybody back.
Yeah, we can start, Samir. Yeah.
We can start.
Yeah, I'm back.
Okay.
Yeah.
Okay. Great. Yeah. So let's get started. Yeah. Thanks. Yeah. So the next one we are going to look at, and you're back to your Google Drive, right? So where we started with agent. Now we'll look at something called as a router. So this is where now we will introduce two agents. Okay. Multi-agent system. So let's open this one. We are taking the current example and trying to expand it to include two agents. Okay. So what are those two agents, right? So what did we do last time? Our agent was simple. It had only one tool, so only one knowledge, frankly speaking. I mean, we didn't have very tight prompt, so it could answer anything else, but fine. I mean, let's say we tighten the prompt, then it is meant only to answer a question about weather. Now, let's say we want to create an agent or agentic system which answers question about two topics. Topic one, weather. Topic two, currency exchange. So basically two unrelated information. And technically, you can have one agent doing both, but again, design-wise, it doesn't make sense, right? What has weather got to do with currency exchange? So you basically imagine that you have conceptually two agents. One agent, which is supposed to handle weather information. Second agent, which is supposed to handle the currency conversion. Okay? So obviously, both will need their own tools. The first agent we have seen, we will introduce the second agent. But now we have two agents. So how do we talk to these two agents together? And for that, there are certain patterns that we use, built-in design patterns, how to talk with the agents. So here we will use a more guided pattern called as a router pattern. And we will see as we go in the code, we'll try to understand that. Okay. So with that background, let's start. Let's connect and get ready our environment.
Sorry, Samir, which file are we opening here? M6 or?
Yeah, sure. No. So, okay. We are already in M6. So when you click on M6, right, it opens a Google Drive, right? And it shows you 4 programs. So make sure you are here. Okay. From there, you're going to open the router. So you're going to right click on this, open Google Colab router. Okay. So now we are in the Langraph router.
Yeah, I'm with you. No worries.
Right. And it's the router pattern which we're going to understand and use. So make sure you install all the packages, and in those packages will ask you to kind of restart. Make sure you restart. It's pretty simple. Say restart session. So you'll always get this message. Make sure you restart. Okay. So this restarting should happen. So here you will see all the same packages except one extra package called as supervisor. So that is what we want to understand. It does. Okay. Rest of the code is fairly similar here, except this supervisor new package. So we import the modules, we set the keys, and how we set the keys. How we set the keys is again here. So you have this key is your Google key, right? And just like last time, you can kind of paste this way, right? And this key is your weather API key. So same 2 keys are needed, right? Same model essentially. Yes. So your pointer to your model is now ready. LLM is now ready. Now instead of getting an agent, okay, we're going to get a team of agents. So that's get team function. Okay. You will find this is familiar. This is copy paste. This we saw last time. You understood it last time. Find weather. We also know this weather agent, right? I think instructions are the same, right? I have not changed anything in the instruction. So it's the same agent, copy pasted. Okay. But now we also have another agent coming in below, which needs another tool or another function. Okay. So what is this agent? This agent is a currency agent, actually currency conversion agent. Okay. So as this explains here, you are a helpful AI assistant capable of converting currencies using tools provided to you. you need to understand user query and use appropriate currency code based on natural language query. Okay, so it's going to get a natural language query. I think we need to fine tune this, but it's fine. This works. So currency codes, right? So it has to work on currency code. That's all we are saying, and make sure that you convert currency using the spelling mistake we have using the tools provided to you. Okay, so what is the tool provided to it? Get currency exchange rate. That is the tool provided. Let's study it. So as you can see, same pattern, right? Follow the same pattern of documentation. So this says that convert the value from base currency to target currency and return the base currency code, target currency code, value, and target value, right? Using some specific terminology. Now input is expanded. It's not just string. You have a value in int. Okay. Base currency code, it is in string, and target currency code, it is in string. Okay. So this we need to explain in the args. What does this mean? Okay. So value, what is the value? Value to convert. We should have been a little bit more clear. Value to convert. The base currency code, target currency code. Okay. All that. Now I'm here also we are calling an outside API for that. Fortunately, it doesn't need any key. Okay, and I managed to find one which does this conversion. I don't know how accurate it is, but it basically calls an external API and calls that it passes the values and all that, and does the currency code conversions and all that, right? And whatever it returns, then we just generate a JSON like last time and get it back, and that gets processed. So this is our second agent. Okay? So far, so good. So we created two agents. Now we have two agents. Which agent we are going to call? You can't. Your program can't decide which agent to call. So now you actually create a third agent. Okay, and that third agent is a built-in agent, just like create React agent. Now it doesn't say agent, but it is an agent. Create supervisor. Okay, so this is an agent. Okay, so let's do a control C of this create supervisor agent. Let's search Landgraph create supervisor. Okay. So what does it tell us? Tells us create a multi-agent supervisor. Okay, so obviously we are working in a multi-agent scenario. Okay, so this is how you create it. What it needs is now because it's a multi-agent supervisor, it needs a list of agents. Okay, it needs a list of agents. It needs models and tools, if any. Now, of course, this agent by itself doesn't need any tools, right? Because our internal agents need the tool, which we have already given. When you said create React agent, we have already given them. So that is needed. There is a prompt, and there are many other things. Let's not go into that. We'll just complicate the matter. Here is the explanation, and I think there will be some examples below and all that. So that's for your later study. Coming back to the code. So like I said, we are just giving it array of the agents that it needs to supervise. We are also giving it a model because it needs to make a decision on which agent to go and how will it make a decision using the model. It doesn't understand anything of its own. It's going to use the LLM model to make a decision whether I should call this or whether I should call this. Okay, doing anything. And a basic prompt which defines its role. So it says you are a supervisor AI assistant. Okay, that's a role. And your goal is to decide which agent to use based on the user query. You will summarize the response from the agents, okay, and provide a final response to the user. Okay. So it's saying that so there is a human and then there is this agentic system. You will act as an intermediary. Okay. So end user need not know how many agents you are using internally, 2 or 20, right? That is what we are trying to tell it. This sometimes it works, sometimes it doesn't work, but let's see what happens this time. So there's a little bit of gochas there, but that's the objective, that it acts like a facade to all the internal agent complexities. Okay. And what is it really doing here? That using the model, it's making a decision. Should I go path A or path B? Okay. That's called as routing. So it basically does routing. Okay. So it acts like a classification model or a routing model in short. Okay. And that's why I called it router. That's a router pattern. And we'll find those patterns or supervisor pattern or router pattern. So that's what. So we create, so this returns you what it calls it as a team, and we call the team and team. That's the team we are going to use. Again, let me pause. Any questions? Or it seems okay, like, understandable, right? What it's trying to do. Okay, let's go ahead. Now there are two examples. So now we are going to, yeah, correct. Okay. So now we are going to ask it a question. So now we know there are two capabilities, weather capability and currency conversion capability. Okay. So we get a team.invoke message, and we do the same printing as before. So let's fire this and let's see what happens. Okay. So as you can see, the response is now not by internal agents, the response is by supervisor. We are talking to the supervisor. Supervisor hopefully is talking to all the internal guides. Okay, let's figure it out if it did that. Okay, now you see a little bit more message here, right? A lot more message here. So what happened? We send a message, human message. Supervisor spoke to the LLM, right? And LLM told supervisor, make a function call to transfer to, basically it's actually guiding it, saying that you need to transfer to weather agents kind of thing. No? It's very interesting. This is the information which it gets back as an agent. Based on that, it understands, oh, okay, that's what I need to do. So it thinks that I have to make an internal transfer. So it's almost like it treats the agents like a tool. So it says, oh, I need to internally transfer to the weather agent. That's the conclusion it makes, right? You can see this name, right? Transfer to agent and weather agent. So it did that internally, okay? When it did that, then weather agent responded back, right? With the AI, with the AI message as output. And what was the output? The weather in Pune, India is better. So it did all the things that we talked about last time, whatever we saw, it did all of that. This message came back, right? Now, of course, the control is right now still with the second agent, which is the weather agent. And that's why weather agent now says, name weather agent, right? So weather agent now is saying that, okay, let me transfer back to supervisor. Because that's what in a multi-agency tick system, in a supervisory model, it has to do that. Transfer back to supervisor. It did that. Right now, that's the tool message, transfer back to the supervisor. That happened. It treats it like a tool message, but it treats all these inter-agent transfer as a tool. Okay, it does that, and finally, supervisor then comes back, right? Saying that no, this is the answer. I think probably did it add any value? It probably did not add any value, right? It just did it reply? Oh, it just added a little bit more value, right? The weather agent provided, it just added that. It actually gave credit. Sometimes it does this, the weather agent provided, sometimes it doesn't. Right. So sometimes supervisor acts like a manager, takes all the credit. You will know what I mean if you have worked in IT organization. That बेचारे developers क्यों ये काम करते हैं, manager बोलता है ये मेरा काम है. Sometimes it's little bit lenient, right? And it says, oh, ये बच्चे अच्छा मेरे एक बच्चा है उसने अच्छा काम कर दिया ना. So this depends. Yeah.
मैनेजर को इतना बदनाम मत करो.
अरे यार हम भी मैनेजर हो चुके हैं.
यशवंत जाग गया.
हाँ यशवंत जाग गया. Okay. Right. Okay. So that's what it does. Now, if I flip it and I ask it a different question, convert 100 dirhams to INR. Now, dirhams is not a code. Dirhams is a nomenclature. INR is a code, right? So let's see how it does, right? Right. Okay. मैं बोल रहा था ना मैनेजर क्रेडिट लेता है कभी-कभी, राइट? बच्चों का क्रेडिट ले लेता है. तो ये देखो इधर वो बोल रहा है मैंने कन्वर्ट किया है करके सुपरवाइजर इज सेइंग. सो दैट दिस हैपेंस एंड आई डोंट नो हाउ टू कंट्रोल दिस, बट या आई थिंक मे बी अगेन समथिंग दैट वी कैन डू थ्रू प्रॉम्प्ट्स.
The LLM is trained on some realities, no? Actually.
Some realities, exactly.
When it comes to money, it takes credit.
और उसको पता है वेदर डाइसी है तो मेरे नाम पे नहीं आना चाहिए.
हाँ नहीं आना चाहिए. Weather information could be wrong. Okay, so if you study the flow again, lot of.
Your voice is breaking in between, so just bring the.
Is it?
Mic nearby, yeah.
I'm on a headphone. Is it still breaking?
No, now it is okay. Now it is
okay.
Yeah.
Okay.
Just sometimes in between it.
Okay. I just adjusted it. Might be internet correction also.
Mm-hmm.
Okay. So here also, as expected, transfer to currency agent. Then currency agent did its job. It made a call outside. It got the outputs. All that. Transferring back to supervisor. All that. So you can see all the flow how it happens internally and the final result. So this is how now we are seeing a multi-agentic system working. There are 3 agents effectively. One is more like a little bit of a dumb coordination agent, supervisor, and then these 2 agents. And then now you can scale, right? Because now you can have many agents, you can have many tools, one agent doing more than what it needs to do and all that. And you can build a little bit more complicated system and use ready-made patterns which are provided by LangGraph to you. So these are value additions of the frameworks, right? That they give it kind of free to you. Well, otherwise, in absence of this, you will have to write a code to go to LLM, figure out, do a classification, toggling, routing, figure out where which to call, and then make the calls to appropriate, do invoke on these. All that is happening internally. Correct, and that's how we can integrate multiple agents together, and each agent with multiple tools also possibly, right? That way you can. So this kind of sets the tone for how you can build more complex system, multi-agent system, essentially. It was failed by tool agent, then who is responsible for results which is generated by LLM or tools? Correct. So exactly. So your try-catch block is basically nothing but a prompt. So at each level, you could have your try-catch, right? Essentially, you can say, if the tool fails for so-and-so reason, then return so-and-so response and all that. So this prompt, which is a very simplistic prompt for our education and learning purpose, could be a half-pager prompt. I mean, your prompt could be as big as 20 lines, 30 lines, 40 lines, whatever. I'll see if I can show you one of the realistic prompt which we are using in our applications. They are like half-page, one-page long prompts. So, Nikhil, to your question, it is either this prompt or this prompt, right? So you have a mini try-catch block here, and you have a global try-catch block here, and things like that. And then you have to handle basically. You have to figure out if there are failures, what would you like to respond back to the user with that way? Okay, so that's the second example.
I just pasted somewhere in my simple prompt, which also is 7 lines. Yeah, you can just as a reference.
Correct. Yeah. Correct. You have a lot of ifs and elses, which you need to include in the prompt. Here, I didn't go into those complexities, but yeah. So if your output contains multiple stuff, like in this case, Prasad output has each question. So what you should do for each question, it's like almost like you're giving a for loop for it, right? For each question, start a new program. It's like saying, okay, for each question in questions, मतलब तुम उसको logic दे रहे हो basically. And finally, try catch block. If you don't find the answer to the questions, that's your catch block, right? In a natural language. Do not answer them. The catch block is empty. But let me know which questions are left on that kind of. So this is how you have to do exactly. Okay. So assuming this is working for all, I'm just disconnecting this one.
Yeah, it is working.
Yeah. Okay. Right. Now, there is a third one, which I am going to leave it more like the swarm. This is also multi-agentic system, but uses a different pattern. There is no supervisor, which means you have only 2 agents, and one of them picks up and they communicate with each other many times and all that. But I'm not going to go into that. This is something you can try. It requires the same set of keys, same similar kind of agents and all that. So you can do this more like a exercise later on after the session, whenever or time. This I'll leave aside. It's a kind of a repeat of this, but a different flavor of no routing agent, no supervisor. Non-supervisory swarm of agents, basically. How do you manage them? So that's that example, which I will leave it right. And then we will go to graph flow. So again, I'm assuming everybody knows that we are basically into the M6 LangGraph agents, and we are looking at drive. And in the drive, you have the graph flow, as the last example, which is where you have a full-fledged workflow that you define. Okay, and that is the example we are going to look at now. So LangGraph graph flow conditional. That's the notebook. That's the program we are going to look at. Anybody has problem finding it? Let me know. Okay. So this is why the name LangGraph comes. because of the workflow. Because the workflow, if you imagine workflows, right, and you'll be actually seeing a workflow diagram also below. These workflows are basically in technical or computer science term, there are graphs. Sometimes they are acyclic graphs, sometimes they are cyclic graphs and all that. So they're graphs, and that's why the name line graph stores information. So when we talk about that, make sure you connect to the machine, install the packages, and restart the machine. Anybody had problems reaching here, this point? Locating the problem, locating the program? Somebody's typing and assuming. Okay, I'll answer that. Okay, so solution to GenAI is exhausted quota reached. There is no real solution. Sometimes what you can do is you can try changing the model. Okay, so because typically this flash model in a minute you can, I think, make 10 calls. If you want to make more than 10 calls, then you just flip the model. And how you do that is you go to Google AI Studio. And I think we are using 2.0 Flash, correct? So let's see what. Yeah. So sometimes you can switch to 2.0
yeah,
Flash
I think
Lite.
Even that 1.5 Flash will also work. Just even if it is not visible, it will make a call. Yeah.
Yeah, correct. It will make a call. Exactly. Or you can try with 2.0 Flash Lite. Or you can keep switching basically. You just switch for being to 2.5 Flash Lite. No, you just switch because they do model-wise calculation. So that way you can switch. But otherwise, there is no solution. The second solution is obvious that you pay for them if you really want it. But free ka limited. Okay, right. So I'm just proceeding further. Now there are a lot more packages I'm going to need. But instead of looking at that, we'll just study the code. Here you need only one key because this is a mocked up example. We're not going to make any actual real API calls. We're going to just understand what is a workflow or what is a graph as it is called and how graph navigation happens. So there is no real tool. There are fictitious tools here. Okay, so all you need is a Google API key. Okay, double quote, and you just put that, remove this and put the key. I'll come back to this little later. Let's compile this. So let's make sure you're all. Yeah, this one is also fine. This also I'll explain later. Let's all come to this step. We compile everything else which is above and come to this step which is called as get graph. Okay, so let's start understanding what is a graph, okay, or what is a graph flow with conditionality and all that. So let's scroll down in this get graph function. Thoda bada hai. So let's go down till you come to this step which says build the which says build the workflow graph. Okay, come here. This is inside of the function get graph. Okay, come here. Let's look at what are we trying to do. Okay, so a graph in technical term, I mean, typically in academics we learn, right? If you want to work with graph, trees, binary trees, this, that, and then graphs, right? Cyclic graphs. So graphs have nodes and edges. Technical term, right? If you have, if you go into data structures of graph, your graphs have nodes and edges. That's exactly what it is, right? So you're building a graph, which is a workflow, which contains nodes and edges. Okay, essentially. So that's what we are doing. So what are the nodes? So there are various nodes. There is a purchaser node, there is a reviewer node, there is an order agent node, there is a reject agent node, there is some other node. And then there are edges. Edges are connecting these nodes together. So purchaser is connected to reviewer. So what we are trying to actually do here is we are mimicking a purchasing agent. I mean, it's really the purchasing agent, right? Purchase agent workflow. You are sitting in your organization and you're talking to your IT department, right? And they have given you a chatbot. So now normally you don't, in absence of a chatbot, you go to your IT help desk and you tell them, hey, I need a hard disk. Oh no, my laptop is gone bonkers. I need a new laptop. I want to just upgrade my laptop, my 8 GB RAM is not sufficient, I need 16 GB, all that, right? You give all these requests to them, and that leads to some internal purchase activity. I mean, there's always a stock, but let's just say that it leads to some purchase activity. So purchasing, what it involves, it's a very involved process, but for our academic purposes, purchasing involves reviewing the request, and if the request is fine, you order it, or request is not fine, you reject it, and then finally you convey back to the user, the human who had come to you, that either you are proceeding or you're not proceeding, or there are more questions because I have sent a mail or I have just made a call. The guy comes back saying which grade you are in, what's your budget, who's your manager. There might be questions. So you ask question and you go back in the loop, right? That way. That is what we are going to mimic it here. Okay. So we are basically saying that a purchaser cannot purchase unless he reviews. So there is another reviewer node or reviewer agent, if you want to call it that way. And what does the reviewer agent do? The reviewer agent will make a decision in terms of approve, reject, or I need more information, which I'm calling it as a user. Okay. If it is approved, then you go for ordering. So there is an order agent. If I reject, then you possibly give a proper reason, maybe hopefully a polite reason. IT departments are not so polite normally, but yeah, I mean, hopefully you give a polite reason back to the user. That's a reject agent. And if you can't do any of that, then you just summarize the answer. You have more questions to the user. You summarize the answer, go back to the user and ask the question. That's what this whole thing is about, right? So we are basically building this graph. Now, it's a little difficult to understand, but I will show you a diagram later on, and that diagram will make it clear. Now, question is these nodes that we talked about. What are these nodes? These nodes are either normal functions or they are agents. So typically, we say each node is an agent. Each node is an agent. Let's look at the nodes. So nodes are basically, again, the same. They are Python functions. They're basically functions, but with a difference that you don't see any documentation here. Okay, why? Because the functions themselves are internally using certain calls to the agents, right? So they are acting like a pseudo. They are just acting like plain function nodes, and they are internally doing agent invocations. Okay. So what is this agent invocation? I'll come to that. Okay. But essentially, purchaser, basically what it's saying that, okay, it's saying that get purchase request from the user, make sure you understand the cost involved, and make a decision and give me the output. Okay. We know that purchaser, we connected a purchaser to the reviewer. So whatever output comes goes to the reviewer. What does the reviewer do? Reviews the purchase cost. And there is some hard coding here that if the purchase cost is greater than 10,000, then reject. You can see this double quoted reject. Otherwise, it is approved. Okay. So essentially, it is giving a response in that fashion. Reject and approve, which is what we wanted. So if the reviewer says reject or it say approved, what we have said is if there is approved, go to order agent. If it says reject, go to reject agent. Let's look at those two agents. Order agent, now it's done. Okay. So it says inform the user that the item requested by his order. I mean, obviously there will be tool call, API call, but we are not doing any of that. We just want to understand the flow, right? So it just does that. Reject agent, inform the user in polite language that the item requested by him cannot be ordered due to higher cost, right? That's what reject agent does. And finally, summarizer takes all these inputs or any more inputs required from the user. It summarizes all that, right? So you summarize the final response to the user query. And how do you do that? By you study the responses by other agents, right? If the order and more information, if it is approved, then or rejected, then do whatever. Or if there is more information needed, so there's a bigger prompt here, right? So that is what it does. So this is a mocked up this thing. There is no real business calculation here, but this is a mocked up workflow of nodes which internally are calling whenever required. They are doing an agent invoke. So what is agent invoke? It's another function which we have written using LangChain, right? And in this, we are taking the input that is coming in, and we are calling the model, right? Responses from the other agent, etc. If any. So we are passing all the responses, and we are forming a LangChain chain and invoking it. So this is a lower level code. So far we saw LangGraph, how you build agents and all that. What LangGraph internally does is this. Essentially, it uses LangChain to make calls to LLM by passing it your prompts. And prompts have static prompts and variables, essentially, right? Whatever variables. So variables are the intermediate communication that's happening. Okay. where is all this intermediate communication which is happening between multiple nodes? Because you are making function call, right? Where is that happening? Every node in a lang graph, graph flow has one constant variable, which is called as a state variable. Okay. So as the name says, it holds the state of the communication between the agents, or it holds the state of the workflow. How do you define this state? So for every application that you have, you define your own state. Okay. By define, so this is basically class. Okay. Class has attributes, right? So input message is also stored. So I have made it very simple. It can be more complicated than this. Okay. So all the responses that each agent is giving is also stored here, so that in the subsequent calls to other agents, if you really need to pull previous responses, you can. So if you want to build complicated prompts based on this, you could. I've not done that yet, but you could do that. And all the messages that have gone back and forth, especially the response messages from purchaser, reviewer, order agent, rate agent, all that, whatever flow it went through, right? They're all stored in a list over here. Okay. So that's my state. So what it tells is, well, LangGraph can function only if you maintain your state. If the state is lost, the flow will collapse essentially, right? Because information in the flow will not get passed on to the later agents or later nodes which are there. So this is very important. This is transient state. What does it mean? That state is only in memory. If the machine goes down, state is gone. But you can have persistence also, essentially, right? There are ways of doing that. We are not going to go into that. That's a little more next level topic of LangGraph. But you can actually create persistent stories, save them in between all. So that's what it is about. You will still not kind of fully grasp what's happening till we actually see a picture of how this flow is. Okay. So let's do one thing. Just compile agent invoke. Make sure you compile get graph. Once you compile, if you come here, this is a placeholder code which does a rendering of the graph. Okay. If you run this, now you'll see a visual picture of what I was trying to describe. Okay. So you can see now this is a graph flow, or this is a workflow, or this is a process. And so those who are used in business process modeling and workflow engines and all that, they would know what we are talking about. So essentially you have a path can bifurcate, right? You have parallel paths or your exclusive paths. In this case, they are exclusive paths, right? This is almost like routing, right? You route, then they join back. So there is a split and merge happening, stuff like that. And there's an end. So every workflow has a start and an end, all that. This would make more sense, right? This will make more logical sense. So how it has drawn this? Because we have given these names to nodes and edges. Where did we give these names to nodes and edges? Here, right? When we define condition, we define the value, right? So it actually plots those values, and on that value, where to go order agent and all that. So this makes it a little bit more clearer how the workflow or the graph flow is being defined. This is, as you can see, this is very prescriptive, right? Which means this is not autonomous in that sense. I mean, there are decisions being made by LLMs, but there are fixed paths, and in that fixed path, what to do, we already know, because we as a organization, we know our business process, and that's what we are trying to plot here using the agentic system, agentic framework. So far, any questions? Because now we're going to run it and we'll get responses. But so far, any question on the concepts of the graph? Because this is a little bit different than what we're doing so far, right? So I just want to make sure you are getting it. Any questions on concept on what we're doing are kind of thrashed out. Is it making sense so far? So the amount of code has increased because obviously we have added so many nodes, and each node is a potential an agent, right? 1, 2, 3, 4, 5, 6 agents are there now. So from 2, we went to 6 with a prescriptive flow. They are not all coming together at once. They are control goes to them based on the conditions, and conditions are evaluated by other nodes, and other nodes are nothing but other agents, essentially that way. Okay. So if you have specific question, Kalpa, you can ask basically. But if not, when you execute, you will actually see what's happening. But generally, this flow, if you have it, so essentially any business process, you logically map in your mind how it is, and then identify, in that process, can I use an agent, or it's just a simple code? No, I just have a condition block, or I actually have a process. I actually have a decision making, and decision making can it be done by LLM? Can it be done by LLM? So every node can be just your own method, Python or whatever based logic, your own logic, or a LLM decision point. Here I have purposely used LLM everywhere, but you don't need LLM everywhere. Some of these nodes could be simply just your own logic, business logic, right, to make decision better. Okay, so let's proceed. Now we'll start executing. So there are 3 different inputs which we are going to try. First one talks about laptop worth 65,000. Now we know that the reviewer has a hard coding of 10,000. So we know what to expect as output. Okay, so let's see what happens. This takes a little bit of time because there are multiple LLM calls. Sometimes if your quota is really exhausted, right, you have made too many calls, this may just not work and you will have to switch, because now we are making at least 6 calls or maybe more. We'll have to see the output in a minute or whatever, right? So some of it may fail in a free systems. 24 seconds, so that's fine. So 6 calls in 24 seconds is fine. So I understand you are looking to buy a laptop. Unfortunately, I'm unable to fulfill your request. Why? Because at that price point, due to the cost limitation. So it's like a little bit nice response saying, "Bhaiya, tu tere aukat ke bahar ja raha hai," right? So it's essentially that. Okay. So if you see control edge, there'll be a lot more communication here. Actually, it's very yeah. Okay. I think. Okay. Right. So human message. Yeah. So human message we know. First it goes to purchaser. अब purchaser ने बहुत बड़ा response generate किया है. And so of course we have to write better prompt so that this response which purchaser is generating is not as big, but it's fine. Okay. Then actually ये इसके बाद reviewer के पास जा रहा है, and reviewer, that's another AI message, and reviewer is saying reject. Model name. Who gave this? It's not printing, but fine. So the reject comes out of the reviewer. So once it comes out of the reviewer, after that, the next message is output by, I think, your reject agent. So this reject agent, we have told it to be polite and all that. So it generates a certain response for you. And then finally, this response then went to summarizer, right? And summarizer then kind of reworded it slightly. That it took this response, slightly reworded, and gave it back. I was looking at the name, but I don't think it prints name in case of graphs. I don't know why it doesn't do that, but we don't. But we can figure out what happened. So if you reverse trace it, you know that it went through that flow. So how it went through, which flow it went through? Purchaser, reviewer, reject agent, summarizer, and output that. So you basically have 1, 2, 3, 4 AMS essentially. So one. There is one in between it. Yes. Yeah. Here also is. Yeah. That way. It went through that. Purchaser, reviewer, all that. And that's, this is reviewer, this is reject agent, and this is summarizer. That way. It went through that flow. Okay. Did everybody get that, or was there any problem?
No, I think it worked.
Okay. Now we'll try the second message. So here the request is different. I want to upgrade RAM worth 6,000 rupees. So I'm very specific that I want to upgrade RAM worth 6,000 rupees, right? So I also specified the cost already. Okay. Now let's execute this. So this is less than 10,000. Okay. So our system should just approve it basically and just order it. So this should ideally go through reviewer, approved, order agent, summarizer flow. Taking time. Noise. It takes more than 1 minute, it will fail. Actually, no, it did come back. Okay, your RAM upgrade version has been ordered. Okay, so again, if I let's quickly look at this. Purchaser. So reviewer said approved. Then this went to order agent, has been ordered. I think this guy just puppeted it, right? Just repeated what has been. Summarizer just had no more work to do. Okay. So that is that. Third one is where I'm a little bit ambiguous on certain terms. I want to buy a new hard disk. Okay, but what is the cost? So ideally, I mean, in the ideal system, they would know the cost, but this is our academic exercise, right? So when you execute this is where there's an unclarity to the reviewer. So it's going to ask some questions back to the users, and summarizer will throw those questions back to the user, basically. So I can help you with that to find the right hard disk. What is your budget? Because see, without budget, it doesn't go ahead. Now my prompt was not very tight, so it ended up asking many questions. But you can make it very tight. You can say don't ask more than one question or ask only the most important question. So your prompt, it's basically prompt engineering technique, which I didn't spend time on, right? So that's that. And if you inspect this, you will find that it actually followed this path essentially. Again, so let me take a pause. I mean, this must have executed, but did you understand it? Are there questions, basically? So open for questions. Or was it too much? But yeah, go ahead.
No, I think no question from my side.
Yeah, I think there was a question.
Yeah. I was, I mean, just overall, if we are looking at graph flow versus what we have built with
so far,
the agents, like the components are different, right? It seems the approach is also different. So you don't really have that underlying build agent
create
functions.
Agent, Okay, no, I purposely left it that way, so I'll come there. Yeah. So this is when you have a prescriptive flow essentially, right? And that is when you are going to use a graph flow. So in a large business organization, large business flow, this is what you do. But when you come to a specific node, okay, so let's go to a specific node and whatever it is, reviewer, okay, reviewer, let's say, okay. Now here what I'm doing, I'm not doing much. I'm just sending it as is to LLM. Maybe this is not what you want to do. Maybe here, instead of using my function, Samir's function, you could do a create thread agent, okay. So you could actually use the internal agents there. Now you may think, well, to review it, I have two internal agents which I want to use to review. Okay. So I will use a supervisor. I will use reviewer 1, reviewer 2. I'll create that agentic system using create supervisor. Okay. And I'll make invoke on the supervisor. And let supervisor do the job. I'll get the response back. So this is essentially a larger structure in your architecture which you are putting, but each node could still use fine-grained, different patterns that we talked about. You could use the React agents that we talked about. You could use swarms, whatever it is, right? More patterns are there. You could use that. Are you getting that point? Did you get that point? What I'm trying to convey?
Yes.
And when you build a large system, you have to think about each functionality and figure out: is it single agent? Is it simple call, LLM call, no tools involved? Or more than one tools involved? How am I going to coordinate? So let me create a React agent, or is it like 2 agents? What pattern? Is it routing? Is it parallel execution? So you have to think like that at every step, right? And then figure out what you want to do. Or no LLM required. Just simply I have an API. I have my logic built into Salesforce. I'm going to call a Salesforce function tool. So just call a tool. You're done. So that's a decision making you as a designer would have to do at that point, right? But this LangGraph then helps you build these larger workflows, which otherwise we're missing, right? You need them. Because if that functionality is done, where should I go? And that where should I go is your graph. You're building that graph. You know where it should go. When you know how your system should flow, like we're talking about loan processing, right? And I think typically this 22 steps are there, the loan approval process, right? You can mimic that using, I mean, typically, process modeling, you would have a overflow of 20 nodes, whatever, right? Or something like that. you can mimic that using this basic line graph feature of nodes and edges. Build a graph, build a state graph. And at each stage, then you can figure out, I need LLM, I need tool, I need multiple agents, whatever, right? That way. And that's where you build a agentic system.
Got it. Thank you.
Yeah. Yeah. Any questions? Any more questions? So you start small. You start with one agent, two agents. You figure out what they're capable of, and then you have to figure out whether I should go to this level or not, or I'm okay with most of my code being non-graph. And at points where I think this is a point where I just need one LLM call or a couple of LLM calls, you use agents. That's another approach. You don't have to really use this, right? You can directly use whatever we saw before as well, right? In your code. There's no force of using this. You can directly do that. But this is the power. If you think you have something like this and it can be retrofitted like this, okay, then this is a good candidate. Langra. Okay, so that is where we finish basically our hands-on. This swarm is something you can try on your own, and I think time front, yeah, we're maybe lagging behind a bit. But if there are no more questions, then this all involves a lot of coding, right? So how do you work in a no code environment? So Prasad, we can probably do that demo, right? 10, 15
yeah,
minutes,
sure.
Like that.
Sure.
Right,
So how we are doing on time?
Yeah, I think we are a little bit behind, but we are still okay.
Yes, we have time. Yeah.
And we took our break, so
yeah.
Yeah.
Okay.
Stop sharing.
Okay. So now what I'm going to do is till now we have seen actually writing in Python. There is still we have to write a little bit of code. But what if you get access to an environment where absolutely don't have to write any code or real minimum code? In fact, that's where there are a lot of platforms which are coming into play, where so-called non-developers can create an agent. Yeah, I think that could be a little tricky to agree to that. But let's see how we can develop agents to automate certain business processes. So what I'm going to do is I'm going to take you to a different platform altogether, which is Microsoft Copilot. So let me share screen. And we are working on this platform for a customer, and then primarily as a part of our consulting, helping them to evaluate this, how they can use for their internal business process improvements. Okay, so what you can see on the screen is basically Microsoft Copilot Studio. Now this is different than what typically Copilot which will come across when you are browsing. So this Copilot Studio is an environment where you can create agents and you can deploy them to automate different tasks. Best use cases for this is when your organization is on a Microsoft 365 platform, where there are lots of integrations are available on Platter, but nonetheless you can integrate with outside systems also. So what you can see on the screen is I have created a simple agent. Now here, whatever the parameters which Samir had shown while configuring create new agent as a part of API calls, now those parameters now we'll be able to see they are there as a part of a user interface. So here is a wonderful agent. There is a name of the agent, DD agent. Now this DD agent is just due diligence, so I've just abbreviated it. And then what that agent is supposed to do is basically this particular agent is supposed to help analyst. And then this for a demo purpose, what I have done is for this agent, I have configured this agent to study Infosys website, so infosys.com, and then also its latest financial call, which happened for the last quarter. So those inputs are also given to this particular agent as an additional information. And what this agent is supposed to do is whenever this agent is supposed to study those knowledge sources and then wait for different analyst queries. Now, how analyst will ask different queries is analyst will send an email to this agent with a set of questions. So let me now show you some set of questions which are here. Like you can see here some set of questions like what are the drivers behind reported revenue growth? Can you break down components contributing to revenue growth, etc., etc., etc. So these are the typical questions which analysts may have. And then these questions, so these agents will receive these different questions. And then once this email is received, the agent is supposed to go through these questions and then answer those questions based on its knowledge. And then we have to ensure, the agent has to ensure that it is not referring to knowledge which is available or the knowledge on which the LLM is trained on. So it should only respond based on whatever is officially published by Infosys on infosys.com and a document which I have uploaded. So if I go back to this now agent definition, now let's see. Now this is like a typical description. It has nothing to do with the functionality. So what it is supposed to do, etc. Main thing what is important here is this orchestration part or the workflow part. And here I have said that use generative AI to determine how best to respond to users and events. So now whatever the workflow which you have seen in the last demo, so that particular workflow here, I have that workflow. I also have left it to the agent to decide. You generate workflow, you generate whatever the path you will like to follow, and then create an orchestration out of it. So total autonomy is given to the agent. And if you can remember from the demo, there was something called as React. So this React is not the React related to the React framework, which is the user interface framework, but this React framework is basically reasoning and action. So your agent is going to reason what is really needed to achieve that goal. So it will come up with a set of steps, and then it will actually execute those steps. So that's how this React framework is all about. So reasoning and action. So in fact, there is an excellent research paper about this React. And then if you are interested, we will also post the link as a further reading material. So that's where the agent thought process, it came into picture. So going ahead, then I'm telling which model to use. So GPT-4o. Now this is the model which is from OpenAI. Microsoft has a deep collaboration with OpenAI, and then here this is how you can configure. You can also configure other models here, but then GPT-4o is the default, and then this mini is another model which you can use. But I have used the latest one. Let me go back. So this is GPT-4o default model, and this is where the prompt which is there. So which is, instead of prompt, they call it as instructions. So instructions are nothing but prompts. Now just go through whatever is there. So basically what this agent is supposed to do, since I'm giving an instruction to the agent, like when a unique new mail comes into my inbox, use the knowledge sources to research the questions that are in the email. Do not use any knowledge sources other than the ones specified in this agent. So very specific instructions. So you will receive an email, go through it, parse those questions, and use knowledge sources which I have provided. So which are these knowledge sources? Here you can see I have provided knowledge sources. So here there is a earnings call PDF which I have provided as a part of the input, and infosys.com. And here you can see I have disabled the web search. So agent is not allowed to go to internet and search for answers. So whenever for answering question, it should simply refer to only these two sources. Now one can add multiple such knowledge sources. So here you can see I can have a Azure SQL, then maybe Salesforce, AI search, and so on and so forth. Maybe a SharePoint site which is inside. So lots of knowledge sources are possible. Now Oracle database, SAP data, and so on and so forth. So I can refer to multiple sources. So this is how I can provide different knowledge sources to my agent. Then the next one is tools and actions. So for this particular agent, our tools are specifically about reading of emails. So here I'm not referring to any tool which is Weather API and all that. So typically, a tool is related to actions. So where I'm going to send an email. So send email is a tool. And also there is another trigger on which this agent will get triggered when a new email arrives. So these are the two key important aspects. So it will, when the agent should get fired and what tool it should use to send a response back. And here you can see all those details I have configured it here is use the send email v2 action to reply only to email sender with detailed response. What should be the subject of the email, etc. Then email should be formatted in HTML. So you can provide lots of instructions to your agent. So these instructions are nothing but prompts, and then you have to keep on enhancing the prompts until it reaches to whatever your requirements are. And this is very important. Is if you don't find the answer to questions asked in the email in the knowledge source, do not answer them, but let me know which questions are left unanswered. So this is very important. So I'm giving very clear, precise instructions. Now these instructions, naturally, they never came up in my first release. I kept on experimenting with the agent responses, and then finally it has reached to this set of instructions. So it is like an agile or iterative process to improve your prompt. And then also there is one more, like at the bottom of the email, let me know what are some good questions to ask the original email sender to discover more about latest quarterly results, etc. So this way you can keep on adding more and more instructions. So I have set all those things, and now this agent is up and running. So now what we are going to do is we are going to test this agent. So let me go back to my email. Okay. Now I'm going to put those questions here. Okay. So these are the questions I'm going to send to this agent. Now let me send this email. So I'm going to, and then put a subject. Now this is very important because I have put filters on the subject. Like it will not pass any email which is coming to my inbox. It will pass only if a subject is due diligence. Now you can put all those filters just to ensure that your agent will get triggered only for a certain types of emails and also for new emails. So I simply put questions here, and then let me send this email. Okay, so I have sent this email. Now let me go back. Okay, now so let's see whether here we go. Now here you can see I have received this email in my inbox. Now both are Prasad Chitre. The email addresses are different. So this is aiqs.in. So I have received this email. Now I have configured my agent to read this my inbox. So let me go back to my agent. Okay. Now, just to ensure that the agent will not get fired for every email, what I have really done is basically I have configured it in a manual mode, so it will not just get triggered automatically. So let me click this test triggered. Okay. Now here you can see whenever a new email arrives, it is going to get fired, and then here you can see the different triggers are already registered. So 2nd August 1303, this is the latest email which it has received. So I will like to start testing my agent based on this email. So this email contains those 7-8 questions which I have sent. So let me just click this start testing. Now here you can see on the right hand side, it has detected, agent has detected that a new email has arrived and it has started thinking on that. So let's see, it may take some time. There we go. Now you can see it has started searching different resources. So based on the number of questions, it has fired those many queries, and it is reviewing the 2 sources which I have given. So it is reviewing to infosys.com and last earning call PDF. And let's see how it takes it ahead. Okay, now you can see one of the question yeah. Sorry.
I mean, the sources are the vectorized database in a vectorized form right now.
Yes, actually, that is all that is under the hood. So I have simply, so inside it has created its own vector database. It has created embeddings, everything it has done on its own.
Right. Okay.
That's the beauty of these platforms. So not only just coding, it also provides an hosting environment, because if you do it yourself, then you need to take care of vector databases, then pre-processing of raw data, and so on and so forth. Now, while defining the agent or creating an agent, I have given these sources. So that was a raw data, and then it has created a vector representation internally. So let's see how much. Yeah, I think one more is remaining. There we go. Now you can see it has got answers to most of them. Now let's wait for it to detect the next trigger, because it is supposed to send a response back to the original email sender. You can see some of the responses like changes in the supply-demand environment, budgets are flat to slightly higher, etc., etc. Now you can see it has formed an email, and the email has been okay. Now the email has been sent successfully. Now let me go back and see whether I have received a response. There we go. Now you can see I have received a detailed response for my questions. It is a well-formatted email. What are the drivers behind the reported revenue growth? You can see it has given an answer. Now these are all from a standard sources. Even there is a link to the source which is generated, and then paragraph wise it has answered this. And this is the real data. It is not from the web. So it has referred to infosys.com and whatever I have given. So this is how you can really automate. Now you can imagine that Infosys itself can put an agent in place, and then rather than their own analyst answering the questions, so maybe different financial analysts can simply send them an email with their questions, and it will answer it and then send it back. So this is how you can automate the task, and then don't have to wait for human agents to reply back. So this is just a simple example of a co-pilot agent. Now you can really do whatever you want, and then have different kinds of activities a part of your agent. Now, so these are so basically this is the path what agent has followed, and so on, so forth. So very, very simple one, but yet very effective agent. And then you can configure for referring to any other tools, maybe database and so on and so forth, without writing a single line of code. Very powerful, but here really, when I say without writing a single line of code, it's not 100% true, because you have to write code in terms of instructions or a prompt, and then you have to understand the domain very well and also understand how LLM works. So definitely some kind of prompt engineering knowledge is very much needed, even if you are working in a no code kind of environment. So this is just a quick demo. I just wanted to show it to you, like how you can even deploy agents. And then now Copilot is coming up with almost every month they are coming up with new versions, and then it can have different capabilities like parsing of input documents or invoices and putting into database and so on and so forth. So lots of automation one can do.
So it would have a lot of tools also, right? Integrations, because if you
yes,
are deploying
absolutely.
internal
So
organization, you might have to
tools.
you can show those integrations, tools. Yeah.
So let me click
that is the real power.
Tool. Yeah. So here you can see these are the different tools. So you can connect to Excel, Outlook, maybe Microsoft Dataverse is again a flat database which they have provided. Then it can connect to ServiceNow, and then there are
you can connect to all, because it will have
all of them. See, these are the tools which they have given. Yeah, so many of them.
They keep adding. They just keep adding every time.
So you
like
don't have
like Zapier, right? Zapier has 7,000
like a
tools.
Zapier, yes. So you can keep on adding for different tools. So you don't have to now develop your config. You have to simply configure the external tool. You don't have to worry about the internal API calls and so on and so forth. So all those details are now available. You can see there is even DB2 connector. So you can connect to DB2 database and so on. Lots of them are there. And then a lot of third-party tool providers are developing tools and deploying on this platform. And you can very easily connect to them. So something similar to Zapier, and very powerful. Yeah.
And if you want to really do advanced stuff like we saw, graph building, workflow building, even that is there, right, in Copilot.
Yes, that is also possible where you can actually.
But it's more complicated. Yeah, right.
Complicated, and now they are pushing for this autonomous agents. Previously, when autonomous agents were not there, then you have to paint your workflow like what we have seen in Python, and then it will run it. So where you have to actually paint, get email, then take a decision based on subject, so on and so forth. Here, I have not done anything of that sort. It has created a workflow on its own. Otherwise, I have to write that, add a node, then that node should have a filter, that incoming email and all that. So that coding is even vanished now in the latest version. And so many, I think these featured ones are most used typically. You can see Microsoft selling their own, or even it has this MCP server. So again, it's a standard protocol for calling external APIs. So the beauty
you want
of
to take any? Sorry.
Yeah, the beauty of this is that you don't have to write any code for integration. A lot of things are available on the platter, but still it is not as simple as it sounds. You need to really master this. It's like configuring or implementing CBEL. Like those who have implemented enterprise software, they will relate to that. You have to first understand domain very well, and then you can implement these tools in an organization. Yeah. Yes, Samir, can add. Yeah.
Yeah. I was thinking any questions if you want to take. So
yes.
So Prasad, here the effort involved in a previous example was only writing that prompt and providing the input document, right?
Not really. Effort. It was an iterative effort because I started with a prompt, then realized that it is not really answering to my needs. So I had to keep on improving that prompt depending upon the responses. So it's like an iterative process. Actually, what you can see is my final output. So it's like my final set of instructions, but I had to spend maybe an hour or so to reach to this particular state. So initially,
I understand. I understand that it is not generated in one go, but it is iterative. But in nutshell, that is what you will come to the final prompt.
Yes, absolutely. So at the end of the day, this is the only thing which I have to give. In fact, if you see the Summers demo, and whenever we are creating an agent, these are the parameters which we are giving it and then executing. So what is my prompt and all that, and then internally it can detect and then execute. So same thing I'm doing it here. Only thing is that there is a nice UI, and then I can monitor, and then I can publish, and then I can even analyze how it has executed. So otherwise, one has to write all that code yourself. Yeah. So very powerful framework. Yeah.
So using my Copilot Studio, whatever agentic solution you build, so using their agents, so the UI and the environment, whatever it is, it will also have a facility to then deploy it, right? So and when it gets deployed on whatever instance on Azure.
Absolutely.
Azure, yeah.
Yeah. In fact, here you can see on the right-hand side top, there is something called an environment. So here, here you can create a deployment environment and deploy it. So it will run it on Azure cloud. So you don't have to go anything beyond this. Actually, just only thing is that the Azure will start charging you.
No, that's true.
Yeah.
So then when it gets deployed on the Azure platform, then what for that particular deployed solution, you get a URL which then is passed on to the user, is it?
Yeah, actually depends upon how the agent is published. Actually, now if you publish an agent as a chatbot, then this chat ka URL you need to send it. So that's where this channels comes into picture. So either I can, so let me just show you something. Now here you can see for this channel, I can publish it to different channels. So channel means how the end users are going to consume it. So either I can put it as a part of within the organization, I can publish it on SharePoint, Teams, etc. But also put it as a web app, native app, etc. But also there is something called as, so see here you can see, like I can even publish it like a demo website.
All right.
Yeah, so that is also possible. So all those UI do not have to develop it, but it doesn't have to be UI always. It can even get triggered when you insert a record into a database, or maybe a new document is published on a SharePoint. So the agent doesn't have to have a UI. It may simply integrate with this different events.
Okay.
Yeah, and then again create a record into a database, publish it on SharePoint, or maybe insert a table into insert a record into Oracle database, and so on and so forth. Yeah. So it's totally running in the background.
Okay.
So just I have not gone through. Typically, it will take maybe an hour or so to walk you through to create your own agent and deploy. We just wanted to give you a very quick idea how really these new platforms are adopting this agent part. So one is everything do it by your own hands, like typical Python code, and then have your own development and also deployment environment. And alternative is this. So either Microsoft Copilot or even Google is coming up with similar platform. Then Zapier also has platform where you can have a generic agents and then deploy them. So Samir, do you want to take over now?
Sure. Okay, so I think agentic was our kind of a core topic. The last topic both of us were debating whether we should even venture into this topic or not. But I think we will, except that I think you all take it with a pinch of salt, and I basically tell you why. Fine-tuning, right? So both of us have been working on a lot of these engagements, startups, this, that, and very few people really actually go into this area, fine-tuning area. So basically, what do? We do prompts, right? We do prompt engineering, and now you saw agentic, right? So it is not just one prompt doing all the magic. You have multiple agents, each has its own prompt, right? And you kind of either view them autonomously as a team, or you build a workflow, whatever, right? And that seems to achieve a lot of the job. But there are some exceptional situations where you would say, no. I mean, this just doesn't work for me, and I need my own trained model. Okay, that's my own trained model is fine today, right? With a lot of caveats. So, and that's what I'm saying, that this is like an extreme step, because it's a very, very intensive step. It needs extremely high skills. Why? Because compared to traditional AI, you always had to create models. And I think neither me nor Prasad, none of us are really data scientists. I mean, I have created a few models here and there in my past organization, but we are not data scientists, right? So we are not really good at that. That was not our core area and all that, because that requires a lot of data science skills, a lot of basic AI skills, supervised, unsupervised learnings, deep learning, neural networks, whatnot, right? And training the models, tuning them, optimizing. It's a vast area by itself, and none of us are not from that area. GenAI LLMs made it simple for us. So somebody in OpenAI, Microsoft, Google, a great data scientist, created these models, fantastic generalized models for us, and we are only consuming them. So we are not data scientists, we consume the work of data scientists, right? And that's why it kind of removes all these hassles of understanding deep neural networks and stuff like that. But when you go into this domain of fine-tuning, you have to understand it. You have to understand a little bit of it, or maybe more than a little bit of it. And that's why it's a tough topic. Okay. So next, this talk, and how much time we have? Okay, I think we can't make it by 1:30, but let's say 2 o'clock. This next 45 minutes are going to be a little bit tougher, even for us to kind of explain, and for you to understand if you're not done the core data science, right? But let's kind of venture into it more like a spectator, more like a viewer. So I'll be also giving a demo, and for lack of time, what I have done is I have already started building my model and all that. I think it's probably complete. So we'll be more like walking through it. Okay. So please bear with me. And questions are welcome as always. So fine tuning. This is what is this? This is an alternative to prompt engineering. What we do here is we don't build model from scratch. We use already pre-trained AI models, right? And which are the pre-trained AI models? I mean, we saw the Google models, there are OpenAI models, there are Anthropic models, all that. And those, I mean, if we really have money, time, and skills, we can actually take these pre-trained models, and we make them adapt or adopt them for a specific task or for a specific domain. So if I'm in a legal domain, and if I'm in the insurance domain, clinical trials, medical medicines and clinical trial domain, right? I want extremely very, very domain specific models which are just focus on that whole generic knowledge about weather kya hai, currency conversion kya hai, it's of no business to me for my business, right? And I want very, very specific models. And I don't think these pre-trained models, Google Flash, OpenAI, Claude from Anthropic, they're not doing the job that I want. This is my conclusion. And that's why I say it's probably 5% or 1% of the cases I would venture into fine tuning. Okay. So obviously, training a model from scratch, that is a job of a data scientist. We are not going there. We are taking the models which are already trained. So we are riding on their trainings, but we are retraining them, okay, for a specific purpose. Okay, and that's what we want to look at. That's fine tuning. Okay? So from bottom up, right? Step one, you get a really large. If you can take a large trained model, but I will tell you what is large. We'll look at it. And venturing into large models is very, very difficult. It's question of money, resources, and time. Okay, but you typically take maybe small or medium SLMs, small language models, or MLMs, or medium language models, and then you take them and you train them. So this is essential, right? You train them only if you have data, because to train a model you need a data. So you have to be very sure about your domain. You need enough data so that you can train the model on that data set, which you feel this pre-trained model have not been trained on. Okay? I mean, like one of my friend is working on an area where they're using vision models, but they are basically training on X-rays and CT scans of chest, essentially, to detect abnormalities. Okay, now that's something, if you give a CT scan or whatever to generic model, they may not be that well in identifying with a good accuracy whether there are abnormalities in that and whether there are cancer detection, all that, right? So that's a very specialized domain. And these models probably don't exist. If they exist, they are very, very costly. And hence, my friend ventured into this area. So that's that. So what he needed was a lot of available X-ray scans, CT scans, and all that, and a lot of pre-canned medical or medical, I mean, cancer experts, opinions on these models, on these images, right? That was this, is there abnormality in this thing, and is it benign, is it not benign, and why, the reasoning behind it. So all of that is needed to train the model. So you need that. And then you go through a training process, and training process is iterative, because you have to figure out many different parameters, and you have to optimize that models, optimize the parameters of the model. So in the demo, I'll show you what are parameters of the model. Because this all now is you're venturing into the topic of deep neural networks, essentially, right? So that, right? So you do all of that, and then finally you get the model out, and you evaluate the output, all right? So you do validations, and if the validation shows it is not good, you go back. So then you again go back, maybe it's your data, you have to again reanalyze your data, readjust your parameters of the model, go back. And you go through this process, and you can't do this on CPUs. You need higher-end machines. You need GPUs to do that. That's why it's very costly. So typically, if you take any large model which are available to you, you would need 32 GPU cores, 64 GPU cores with 128 GB RAM, 256 GB RAM, something like that, or multi-machine GPUs and all that. So all complexity comes into that. That's why nobody really ventures into that. And GPU will cost you something. One GPU core will cost you something like $4 or $5 an hour. You are charged per hour, right? You book the GPU. It's not pay as you go most of the time. I mean, there are some vendors who give you pay as you go, but most don't, right? So cost is phenomenal, right? You need real deep pockets to do that. Okay? But anyway, having said that, this is the fine tuning, and like we talked about the example, that those could be the examples where you would like to venture into it. So if you really venture into it, what do you get? You basically have trained your models through fine tuning. So once you have done that, your runtime cost is less, essentially. So runtime is less, your domain specific accuracy just goes up, right? And you can start applying these fine-tuned models to very niche fields in figuring out something which your LLM, large language model, cannot do, because large language models are generalistic in nature. They're not specialized, okay? All that. And obviously better efficiency, because now, if you look at large language models, the data that they use, they talk about like what 1 trillion records were used and all that. You don't need that in fine tuning. You are going to use probably less than 1 million, maybe 100,000, maybe 10, 50, 20,000, maximum million records. So you need much less data and you get much better efficiency in the output. So these are some of the things, and that's why you could use them in specialized fields like healthcare, legal, finance, and also for creativity. Very specific creativity in generating maybe specific cartoons, whatnot, right? Or specific drafting research papers for, I don't know, psychology or whatever, right? All that. So you can create, you can use them for very specific purpose. So that's the background. We did not go into comparison. Now let's go to the demo. Before I go into that, any generic questions which you have on fine tuning? Because I know I'm talking very little about it, and there are many advanced things over here as to how you optimize and all that. But I'm trying to avoid going there. But that's a very heavy topic.
So yeah, so we saw RAG.
Yeah.
Where we brought the organizational knowledge through documents.
Correct.
Into the overall process, and whereby the response was more accurate, and then fine tuning. So
yeah,
what is the
so RAG is an alternative to fine tuning, because you have your organizational knowledge. You think using generalistic models, generalistic large models, if I can somehow manage to find the right slice of information, retrieval, I can achieve the retrieval well. Generalistic models will be able to give me answers. But when you conclude healthcare, medical areas and all that, this doesn't work. It's not going to work, right? Or LLM, even if I give it the data, for example, I give all these 3 scans, right? It just cannot figure out what I want. That is this a benign cancer or not? Or this is benign thing, or there is a cancerous stuff. When you conclude that, so when this fails, you will go to fine tuning essentially, and the cost is phenomenally high. Essentially, in this case. Yeah.
So then the fine-tuned LLM,
yeah,
and what they are talking about SLMs, small language modules.
Yeah.
Are they same or two different stuff?
No. They're different, two different. So SLM is where it is trained on a lot of data, and it's a huge model, right? So if I want to deploy the model, I need many machines, many GPUs, much RAM and all that. Small models are scaled down. LLMs are that. SLMs are scaled down. They are trained on much lesser data. They need a much lesser GPU, CPU power to run, things like that. But they are less accurate. They are very focused because they are trained on less data. So they know less, they can answer less information, right? And so all that. So that's SLM. So you can use LLM or SLM both in RAG. You can use LLM or SLM both to fine tune. That way. So input to RAG can be LLM or SLM depending on your use case.
So let's say, for example, the use case is about analyzing X-rays of chest.
Correct.
Then taking an SLM
that's all that is there, right? That is, yeah. Then you take a SLM exactly, because you don't need LLM. Somebody who can do language translation, somebody who can figure out whether you don't need that, right? So then you can go to an SLM, pick up a SLM, and then go through training. Yeah, exactly. Then go through this process and do the fine tuning. Exactly. So you're right. Like, fine tuning is typically done on SLMs, but not necessarily. Typically done on SLM.
Okay.
Yeah. So typically it is like when they relate, like fine tuning is like you have completed, let's say 12th standard, and then fine tune yourself, whether that's an engineering, if you're going for engineering, then fine tune with a different branches.
Yeah.
So learn that data and then you become an expert into that. So core is 12th standard as a basic one. and then customize further. And key thing I think for RAG is you can have access to more dynamic data, because you don't have to keep on training again and again, because training is very costly than pre-processing for RAG. So fine tuning is a static model, so it can't change. So it is just like you train it and keep it, then make it ready. RAG is more dynamic. So
RAG and prompt engineering, your core model's behavior never changes. It forgets you, right? You talk to it, whatever context you give, for that context it gives you response. It's done. It does not remember you, right? It's stateless. In fine tuning, it remembers your data because you trained it. It has configured what we call as internal weights as per your data. So it understands your data, and hence it doesn't need any extra context to be provided. You're giving it the prompt, it gives you back the answers, basically. Because the data it has already seen and learned. Yeah.
Okay. Super specialized model, actually.
Super specialized model. Yeah, correct. Okay. That with that minimal, I know. I mean, fine tuning. If you want to take us a topic, I don't know. I mean, we are probably not the right guys. It might be a 3-4 hours topic, but we are just giving you a test of it, and also discouraging you that this is something that you should refrain from. But we're just giving you a test of it. So it's more like look at it as a fun. I wouldn't say we are teaching you anything on that and all that. No, but that will be too much to say. But yeah, because we ourselves are not really expert in that. But yeah, I mean, it's a good fun to look at, how the behavior changes. I'll show you that. So if you go back to our traditional link of notebooks, there is M7 fine-tuning Hugging Face models. Open that. Okay, you're not gonna. I mean, basically, you open that, you will land here in the drive, and then there is a fine-tune FLAN T5 medical IPYNB. Right? Open this in a collab, but you're not going to run it. Okay, it takes long time to run. So I started the process long time back, 20 minutes back. You can run it later on. Okay, right now just watch and learn, basically. Okay, that is better. Okay, so open it for your reference, but that's about it. Don't do anything else. Okay, so when you open it, forget all this. It'll open the traditional notebook and all that. So I ran it, and I'll tell you why I ran it. Okay. Okay. Because this process is a long process. Okay. So before we go into the code, what are we going to really, how we really fine tune things? Okay. So there are a few basics which I need to tell you about. Okay. So the basic number one, okay, we are going to fine tune a model from Hugging Faces, open source model. Okay. So what are open source models? Where do you find them? So you find them here. Okay, this is one of the places. There are many places. So let me just put it in the chat. Something for you to study. Hugging Faces. This has become a de facto place. A lot of open source models. Open source models are the ones which you can download. Okay, so everybody, Microsoft, you can see Microsoft puts their own models here. Okay, Google will put their open source model. You will not see Gemini models here. You will see Gemma models here. Okay, which was that company of that DeepSeek. Okay, so you should see DeepSeek models here. All that, right? So there are many models here. Most of them are fairly large. Okay, but you find the models there. That's a good part. Second interesting thing is you will find a lot of free data sets here, right? So I think we talk about medical data, right? So you will find some medical data sets, and you have to really go through it to figure out, what that data set is all about. You'll find some legal data sets. So you have to really study. I mean, not all are useful, most are useless, but you could find some interesting training data here. Okay, so these two things that you need to know. So what basically you do is you pick up a model, you download it, and I'll show you which is that. Then you pick up a data set, and using that data, you train it. And obviously, we are going to pick up a real small SL model, like you said, Yashwant, right? And that's what we're going to train. Okay. So this is the basic. Now, this is all fine, but to train, you need certain different APIs, right? Now we are using Hugging Face model. So we will be using Hugging Face APIs, okay, in this case, because that is what typically you use, but it's not necessary. There are other competing APIs that you can use, right? The traditional ones. Google TensorFlow APIs, right? Or core Python level, you have Python, PyTorch, way of building training model. This all require, and that's why I said it's all adventurous game, because it requires a fairly good machine learning know-how. So one has to really go through machine learning training programs to really be able to do that. And that's why I said don't execute, just watch right now. Okay? Okay, so yeah, so I have already run this. So I'm basically going to install a few packages. One package comes from the transformers. Okay, now transformers is the real architecture behind LLMs, right? And we probably perhaps purposely didn't cover that, but let's do one thing. I think yes. So we are going to use the transformers API. Okay, which is provided by Hugging Face to train our models. Okay. If you say Hugging Face Transformer search on the web, you will find this API. So what does it tell us? Transformer act as a model definition framework, okay, for machine learning models in so and so. If you want to do machine learning of the models, you use this framework. That's what it's telling you that. It does a lot of things. It's basically meant for the models which are based on the transformer architecture, which are the SLMs, LLMs, no, all that basically. It is meant for that. Okay. And what feature it gives you? It gives you many things. Our interests are trainers. So it gives you a lot of trainers, right? So built-in trainer APIs, which and now we are venturing into a little bit advanced topic. So what is training? In training, you actually take a data set, you take a data record, you load the model, and you tell the model this is the input, this is the output, and adjust your internal weights, your learnings based on that. Now, what are weights? Okay, I'll come to that. Come there, right? But that's essentially you're doing. You're doing training, and that training requires you to give a lot of parameters. It's a iterative process. So there are various ML terminologies, feed forward, feedback, backtracking, all that. Again, completely out of syllabus. So if you go here, you'll see all of that. So there are terminologies like loss and weights and all. I don't want to go there because it's like a 2-hour, 3-hour, 5-hour stuff. Okay? But essentially, there is a package. That's all I want to convey to you. Okay. And you want to pull data sets from Hugging Faces. So there's a data sets package. And we are going to use Hugging Face API, but it internally uses PyTorch model underneath it. So we need that. Okay. So this is what I've installed already. Okay. Before I go there. Right. So far we were using CPUs, right? But now we can't use CPUs. We need a GPU. So I have basically picked up a free GPU, which is available, T4 GPU. This is the one of the worst, whatever the cheapest GPU that you can get, and you get it for like 2-3 hours, 3-4 hours, and all that. That's all for free. And what it gives you is it gives you RAM, it gives you hard disk, and it gives you there is a GPU core, which you don't see, you see here, and it gives you a GPU RAM of 16 GB. So you have to make sure, and it gives you only one core, right? So you have to make sure you can fit your programs into this. And to fit your program into this, either you have to choose your model, SLM model correctly so that it can fit there. Or if your model is larger, then you have to optimize the process. Now, in this today, we are not going to go into optimization. That's a fairly complex subject, right? We will take a model which fits in here so that I don't have to optimize. Okay. What is optimization? We'll talk about this later if time permits. Okay. Now, what is a training process? I have given here a link. And there is also a diagram here. We are going to use Hugging Faces API. So I'm going to follow the Hugging Faces procedure of training. Plus. Okay. Yeah. So the process is like this, unfortunately. Okay. At the top, it says install required libraries. We're going to do that. Then it says load your data. Okay. We're going to do that. Obviously, you have to load your model also first. Then you load your data, sample data. Then if customize, okay, so this step 3, forget that. Step 4, fine tuning. How do you fine tune? So here is where you load your pre-trained model. So this is important. You're not doing it from scratch. You load your pre-trained model. What is a pre-trained model? Pre-trained model. So it is pre-trained. So what it has learned? It has learned some numbers. Okay. And those numbers are called weights. So basically, loading model is synonymous to loading weights. Okay. And I'll show you what those weights are. Okay. Now you're going to train it. So you need to give it training arguments. Okay. And you need to decide how you're going to train it. Okay. So is your input, what do you want to do? Text in, text out, number in, text out, text in, number out, text in, classification out, all of that. So there is various ways of training. So you have to choose your trainer appropriately. And then you train, okay, basically, which is also called fine tune. Okay. This is the process, okay, at a higher level. So if I go into my code, let's do that. I collapse this. Okay. So that's what we are doing. So we install the packages, okay? Then we do some initialization. We load. So I just reverse the process a little bit. I load the pre-trained model first. I'll tell you why. Then I load the data. Then I train the model. This takes the most time. It has taken the most time. And then I inference just to check how the model is functioning. Okay? That's the higher level process. Okay? Now let's go through this process. I've already gone through this process. It takes 20 minutes, and I don't want to waste time. So you load all the packages. I'll not probably go into that. Now, interesting things. Now you are going to decide. We are going to decide what SLM we're going to use. Okay, so here is the model. Okay, from Hugging Faces. So if I go back to Hugging Faces and paste it here, Google Plant. This is one of the क्या बोलते हैं, poor man's most primitive model that you can get. Okay. For every model there is a lot of information how it is trained. It's not that bad. It's pretty good model, but it's not very intelligent. So if you want to know little bit internals of these models, if you click on the file tab, and these things, if you want, if you can do it parallelly on huggingface.co. I have pasted that link there, right? So Google Flan-T5 base, right? This model. So first thing is size. So you can see this is the size 990 MB. This is very nice. This is just 1 GB. Okay, so it's one of the smaller models. Okay, if you okay, in competition to this, okay, just if you want to see DeepSeek, to sabne suna hai, DeepSeek R1. Okay. Let me take that, and that model is also available for download. Okay, but there are so many parts to it. So you can see it starts with 5 GB, and there are so many parts. You keep scrolling and keep scrolling, keep scrolling. Load more. It has not ended. So you can see why, right? It doesn't end. So these are huge models. LLMs are huge. So you really need guts to download them. You will never have money to run them because the kind of GPUs they need. I mean, it's impossible, right? So it's not something that we can play with. We can play with 990 MB. Okay, you can use this. So there are various flavors of the models here. Again, this is machine learning stuff, so I don't want to go there. So we will use what we call as the PyTorch model essentially. So that's what we're going to use. Okay. Okay. So that is the models. We have defined this model, and we need a medical data set. I'll come to that a little later. Okay. So we defined this. Now we load that model. Okay. In memory. So in memory means what happens is this model is huge. So we need this model loaded in our GPU because there are so many internal calculations happen, right? Within that with CPU, it will take like 10 times, 20 times more time. So you are all these 4 hours, 3 hours will run out, right? You don't want it. So you definitely need a GPU for that. And you need GPU RAM for that because GPU RAM is situated on GPU, right? And that's how it works. So there are so this is where Hugging Faces comes in. They give you many ways of loading the models. Again, I'm also kind of a novice. So typically novices like me use auto models, right? You just use auto models to load these models. And then you use NVIDIA library called as CUDA, right? So these are NVIDIA GPUs, and that's why NVIDIA makes money because to communicate with these models, you need specific NVIDIA libraries. And that's the CUDA library. So on the top, if you see the installation, you will see some of the NVIDIA stuff here, right? NVIDIA, all that. So it loads all those models. Okay? And that's how your model and in future, later on, data will get transferred to GPU. So that all, so you can see this, I went through this process. It loaded the 990 MB model and all that. And then that got loaded there and all that. Now, what I did was, I did a basic test on this model. So I'm interested in my medical. I have a medical question which I'm asking to this model. And I know it is not trained on that. So I asked the question, what are the symptoms of diabetes? And I called the model and using the Hugging Faces API, right? So studying Hugging Faces API itself will be like a day's work. So again, just take my word for it that this is how you do it. And you see the output. So it says symptoms of diabetes, swollen rectum. This definitely is not a symptom of diabetes. Okay, so oh my. Okay, forget it. Let me walk through this process. It's the model, right? Okay, channel. Yeah. So okay, okay. So it gave an output, right? And this output is not the valid output. So we know the model is not trained. It doesn't understand. It doesn't understand medical question. Okay. So now what we do is we want to train it. Okay. So we load a data from where Hugging Faces. So I managed to find kind of this data. If I go back to Hugging Faces and paste that data path. Right. So this one is the interesting one. So this has basically instruction. What are the symptoms of the hypertensive disease and output, right? And it has both ways. If you give symptoms, it will tell you the cause, and you give cause or you give the disease, and it will tell you the symptoms that way. So it trains on this. There are 10K records available, which is not good enough, but for academic purposes, this is good enough, right? So this is the model we are interested in. Not even the full model, because I realize things time out or they take long. So I'm just taking 30% of it. So so when I load that data set, I'm telling it I want only 30% of it, right? So I do that and I eliminate some junk data from it and all that, right? So my data set is ready in this data, which I just print the length of it. So out of 10K, 30%, so 3033 records we have. Okay. So now we had those records. Now we do a pre-processing. Okay, so now that data is in a certain fashion. Okay, I want to convert this into a prompt. So I want to say, this is the instruction. If I ask you medical question like this, your answer should be like this. So that's a prompt. So to build a prompt, I write a pre-processing function and I build a prompt here. Okay, there are some technicalities involved here. So that's fine. So I build the prompt. But like we said always, right, the machine learning's models don't actually understand text. Okay. So that textual prompt, then you need to tokenize. Okay. You need to basically convert it into numbers. How do those numbers look like? This is how the numbers look like. A vector or a matrix. If you want to call matrix, that's what it is. So you basically convert it to a vector. And this is the number you give it as a kind of an input, right? So there's the input and labels, essentially. So that's how the whole data is generated. This is what you feed to the model in Hugging Faces way, or even in the PyTorch, this thing. You feed the numbers and you train the model, okay? Some mapping function. Okay, now, so same thing. So this is what we are actually training it on. This is an example of a data 2, second data, that what are the symptoms of hypertensive disease? Answer is the following, and actual data which we are going to feed for training is this data 2, which is this, whatever I showed you, right? These are the numbers, the vectors, which is what we're going to feed it. Okay. Now, when you train, you also need to make sure that you built in a testing loop, within the training. Okay, so what we do is, out of this data, we say 20% you use it for testing. So 80% for training, 20% for testing. So 3000 record gets split further, okay, with a certain seed and all that. So data gets split into trained data, test data. So as you can see, trained data, test. Of course, now it's all numbers. So from this point, we won't understand anything. It's now meant for the machine. We use some internal classes which help feed data properly in batches. Okay, not one record at a time, but in batches to the model. So our data is ready. Our model was already in. It's all gone. So I won't be actually able to show you the it running, but let's understand the process. Okay. Right now we start the fine tuning process. Now, here is an interesting thing. So we talked about the model, right? And what the model is all about and all that. So let me show you something interesting, because without which perhaps you couldn't be able to make sense of it. Just give me a second. Yeah. I have to talk about this without which it's a little bit different. So that whole model that we are talking about, what is it? It's basically a neural network model, okay? So, so when the model is noded, it's basically a neural network. A neural network has layers and nodes. In each layer, there is a node. So there is an input layer. There are many internal layers here, and there is an output layer, right? In each layer, there are multiple nodes, from 8, 10, 12 to 9600, whatever, 200, whatever. The bigger the neural network, the more time it takes, but the more learning it will learn automatically. So this is a deep learning topic, but all you need to remember is there are nodes and there are layers. Okay, that's all I want to do, you to kind of understand. So the model that we have loaded, right? It is when it learns parameters. Okay, so what is a parameter? So let's take a simple use case. If you are building a model that area in Pune, name of the area, number of the area, pin code of the area, and standard rate for rental rate, let's say, or maybe land rate, right? If you're not going to purchase rate. So Deccan Gymkhana, whatever, 40,000 rupees, whatever. No, Curve Road, 12,000 rupees, right? So now we are talking about two parameters here. Okay, parameter one is the whatever that location code, and parameter two is the amount. Okay, SLMs, small language models. Okay, see how many parameters they have. Okay. So, yeah. These are the number of trainable parameters. This is about how much is that? 247 million parameters. Okay, that is what the model that we are using, Flan T5, even though I said it's a kind of shitty model, it still understands, I mean, it still internally has so many parameters. Each parameter, I mean, it's trainable on so many parameters, right? And how many layers? So we saw 3 layers. It has 12 layers. I not printed other information, like because each layer, then I have to go in the loop and figure out how many nodes and all that. This is just to give you idea. And weights, right? So in each layer, there are various, in each layer, there are 768 into 4, so many parameters, so many trainable parameters. So basically, all I want to convey to you, this is a gigantic, I mean, by any machine learning perspective also, these are still a gigantic models, okay? And you're going to train, now, what kind of training we're going to do right now? We're going to train all the parameters, and that's why it takes time, okay? So we're going to train all the parameters. Do you have to do it this way? No. If you have more know-how about it, you can optimize further, right? And you can train only few layers. You can say out of 12 layers, only top 2 layers, if I train, this should work for me. Who can make that call? A data scientist. Because you need a data science knowledge to kind of go through this iterative process and make that work. That's why I say it's a very, very adventurous topic, essentially. But yeah, giving all that, now we start the training process. So training arguments and trainers, that's what we need. So training arguments is where you make a lot of decisions. You decide, like I said, I don't have too many resources. I didn't have too many resources. My resource is gone already. But anyway, so I'm going to tell it, boss, learn slowly, basically low learning rate. So don't consume my resources. And I will give small data batches at a size at a batch size at a time. So even though I have like 3,000 records, I'm not going to give a batch of 100 to it because I won't have enough memory. My GPU can't handle it. So I'll give small batches, 10, 14 batch of records to learn and all that. Right? So that all configuration you do here. And then you're also going to tell it you should do training and you should do evaluation. Okay. And then I'm setting a batch size that which is basically my steps. So about when I do about 100 100 cell batches, make sure you learn and make sure you validate. So after every 100 batch, you do a validation. So all that stuff, and this requires a lot of study basically on how you do that. Okay, so you do all of that, and then you create a trainer, and trainer is a class given by Hugging Faces. To that, you give the model that you have loaded, you give all the arguments, you give the data split into training and evaluation data and tokenizers, number converters, and weigh a reader of the data, how to process the data. And then you basically go into training process, which I obviously went through, and it took about 15 minutes. Okay, so even with 1 GPU and only 3,000 records, it took about 15 minutes. So it's an iterative process. Like I said, after every 100 batches, it calculated a training loss and then it did the validation and it calculated the validation loss. This tells, I mean, this is again a technical subject. This tells us these training weights are not good. When are they good? When they fall below 1. Now, actually, the training loss did not fall below 1, which means I need more data or I need to have more learning rates. I need to spend more time in training and all that. I didn't do that. But at least the validation loss was below 1, which means I think it's able to validate in a much better fashion. That's what it means. Okay? So that's what I did. And then it created a model and then my system has gone off. Now, because my system is cleaned up, my model is gone. So now, unless I go through another 20 minutes, which we probably don't have, reallocating, I think it's gone. Is it? Oh, no, sorry. It's there. It's there. It's there. Wow. Okay. Good. Sorry. Okay. Model is there. Let me make sure I save it. For a moment, I thought it cleaned up the resources. So now the model is ready, and now I have saved the model in a local directory, AIQS medical, whatever, right? So here are the models. I mean, it saves many things, but model saves insert. This is the model. You can see the size. It's on the hover it shows 944 MB. So about nearly a GB of memory. This is again. Yeah, because this is a tricky affair that GPU, free GPU, 0, gone. Sorry, it got cleaned up, guys. Sorry. I don't think I will be able to show it to you. Yeah, okay. Anyways, this is something now you can try yourself. And inference. So now when you ask this question, it will be able to give you good inference. So I didn't run this. I wanted to show it to you, but I think my directory is cleaned up and my GPU is cleaned up, and we don't have 20 minutes. But that's the whole idea. So, and then now if you run it, you will actually see output. So if you ask it the question, you will get the output. And if you ask it a random question, obviously it is not trained on that. So it will give you garbage, right? All that. But for these, because there is a lot of turning has happened, it will give you right answer. This is something now probably you guys have to try it yourself, because here we are at the top of the hour. I think we are 2. And this one is training process at 20 minutes process. 15, it's not 15, it's more than that. It's a 20 minutes process. So sorry about that. I think my GPU got reclaimed twice. So I can't show you the inference right now. But now let's talk about it. Essentially. So questions, and Ranjana ma'am has some questions. VIT and ConNet are giving poor results on my medical dataset. How will be useful for me to? How will this be useful? So on next, how big is that data and all that? I mean, when you say poor result, and are you doing traditional machine learning, ground up model building, or are you trying to use LLMs, SLMs to train? You can give more context. Ranjana ma'am. Acha. So how will this be useful for me for this? Okay, right. So if your data set, if you can study the data set and basically figure out how it is organized, and like I did, right? By looking at the data set, if you can convert that into prompts, because now we are used to prompts, right? So write functions to convert into prompt and go through the training for cluster of 100 images. No. Images, you will need good GPUs, and this SLM which I showed you is not good enough, because you can't train the text-based models and train them on images. You will have to find a SLM model which is vision trained. And I'm pretty sure the model which we looked at is not vision trained. So you will have to find vision trained models, essentially, vision models, essentially. And SLMs for vision, which I'm not aware of right away, and then train them. Because the basic computer vision training should have already we need a pre-trained models for fine tuning, right? So the pre-trained models that you use has to be vision trained, which means input image, output text. So, and which are large models, essentially. I mean, the small models over there will be also large models. And you can't use Golab, obviously. You will need paid environments. You need AWS, Azure's, and all that. Only then you can train them, really. Okay.
Samir, you mentioned that 20% for testing. So what does it do?
Yeah.
Next 20% record, it try to validate against whatever it has learned in that.
Yeah, exactly.
But how does it say that result is right or wrong? Like, I didn't understand
that. That is a question which is a deeper question. So, this is basically numbers are going in, numbers are coming out. I mean, I will have to be little right? So this question is converted to number, this question is converted to number, right? So numbers go in, numbers come out, right? So when you train, when you do this, internal weights are calculated by the models, right? So there is certain weights calculated. Now in the validation, So when in the training process, only weights are calculated. Okay. In the validation process, using those weights and using this diagram that I showed you, so numbers are passed in and output comes in. When the output comes in, your data also, because data also has output, right? And model predicts an output. So now you have two outputs. You compare them using ML functions called as loss functions. So you calculate loss. Okay. Don't ask me how you calculate it. That's a deeper survey.
No, that's okay.
And if the
so it converts
if
both,
the
it converts
loss
both
is
into numbers and
correct, yeah, and it compares them and calculates loss and sees how much loss is there. So if the loss is low, the model is good. So it tells you what is the loss. So 1.25 is not a good validation loss. Below 1 is a good validation loss, which means the answer was nearer to what it should have been, basically. That way. And that's how it basically validates. So training process calculates weights.
Loss in layman's term, can we say mismatch?
Mismatch. You can say mismatch. Exactly. Yeah. And I didn't go into that, but in the training arguments, you can configure loss functions and whatnot. I didn't go there, but yeah, it's pretty involved process. Traditional machine learning process, basically. So you configure a loss process and you configure how the gradient slope should be, a lot of things. But yeah, that in short, yeah, short answer is that, yeah. I mean, it's a deep subject. So ideally, before you go to fine tuning, one should do maybe a 1 or 2 hour, neural networks and deep learning, kind of a training. I don't know whether Prasad I can actually do that. Maybe I can, but and then only you venture into this topic. But then all these terms, kind of start making sense eventually. What it is, yeah. But just wanted to tell you that okay, I mean there are interesting things like this that if some organization says that we want fine-tuned model, you have to really counter question them. Do we have data? Do we have money? What kind of data? Like images, like Anjana was saying, okay, then let's first figure out what is the cost of it. Why we can't use existing models which are out there, and you just pay per call, right? Per API call you are paying. So per API call $0.002 or something like that, right? Versus these models, right? Allocating huge GPUs and loading also, right? When I actually run this model, I need a GPU to run them. So I need my own GPU to run the models, right? When I load them, I'm actually saying in inference, right? While running, I say put it to CUDA. If I don't, the response will come after 1 minute. If I put it to CUDA, which means I put it on GPU, the response will come in 5 seconds. Right? That's the difference. So you need them. And that's why I counter question that. Do I have right data? Can I do cleansing of data? Do I have a data scientist with me who can understand these terminologies? Then venture into this. And can I really deploy these models in a large scale? Right. So because the model, when you deploy on a GPU core, if you make concurrent 5 calls, maybe your GPU has maybe only 2 or 3 threads. So 4th and 5th call will wait. Now what do? So I need more GPU cores. Then you will reach a machine limitation. Then you will need multi-machine, multi-GPU. So it's all a dicey game. Very complex game. The deployment is also complex. Okay, so I hope I didn't confuse you much, but just wanted to give a test of what a training is. And this is nothing new. Anybody who has done machine learning knows that training loops, what are they and all that. And there are many things here, but with LLMs, SLMs also, you could actually go through this process and get some interesting result. I can't show you the result. Maybe I'll send you the output of these results, and you yourself can try with T4 if you are patient and go through tuck stepwise and 15 minutes wait time here and all that. You should get good outputs here. This should just flow through. No other keys needed. Nothing needed. So do try this. Though every line will need its own explanation, and I can't do justice to that, but yeah. So that's about that, and then let me stop here because we are exactly at cross right now. I'm stopping it here. Yeah. Okay. Okay. Yeah. So open for any questions. I know we are just over 5 minutes, and we couldn't finish at 1:30, but yeah. hopefully, I think there was something that, especially the agentic part is very, it has really picked up. And that's something that one should look at once you get a hang of basic LLM. Agentic is something that you should really look at. Evaluate other frameworks, look at other frameworks and compare and see what is useful.
No, nothing from my side.
Okay.
Hi, this is Kalpa. I have a question around the actually one of the other participants asked a question about how do we evaluate the accuracy, and then there was a response on using Raga's model.
Ragas. Yeah, Ragas is one of them. So, yeah, right. I mean, because see, traditionally, if you had those machine learning, if you're in a supervised machine learning, right, you know what outputs are going to come typically, right? Because it's a classification exercise, so you know finite outputs. So you can actually do many calculations in terms of accuracy, all that, right? F1 score, there are techniques there. But here the outputs are textual, right? So how do you evaluate them? So this has been bugging maybe for 1.5 years, the whole LLM community, right? So now there are frameworks which internally use another powerful LLM, like OpenAI's and Google Flash and all that. So they use the LLMs to actually give them back the same input, same question, same context and answer. And they say, you please evaluate and give me back in terms of contextually, was it correct? Accuracy, was it correct? Do you see hallucinations here? So there are about 4 or 5 parameters which Ragas talks about. So they come back with some scoring. So they do some scoring on these outputs which come out of your current LLM. So RAG output, whatever comes, which is coming anyway from LLM, you pass it to Ragas framework, which uses another LLM to evaluate, basically. So that's the technique which is now kind of coming into the picture. So you use evaluators, and these are the LLM-based evaluators. Second technique obviously is human feedback, right? And that has been, in fact, most of these companies, OpenAI and Google's and Anthropics and all that, they use human input. So RLHF, reinforcement learning through human feedback. So if you see, when you do chatting and all that, you have those like buttons everywhere. And when you click like, earlier you could just like, now it asks you for some comments. Basically, it's asking you, why did you like this? What was the reason? So many times you give a reason. So that input goes in and sits somewhere. So that's the feedback that is getting collected. And every system which uses LLM today, also tries to collect the feedback. And then some human can look at it, because you also need domain experts to look at it and say, the comment, whether it's a genuine comment or the guy is bluffing or no, he doesn't know and he expects something else and something. So you basically filter the data filtering. And then what remains, you take it back into your training process. That's what Google and Microsoft and Anthropic and everybody does. So that's a reinforcement. So you say, if you answer it this way, thumbs up, right? Basically, then I give you positive points. Reinforcement learning is all about that. It rewards. So you will be rewarded if your answers are matching this that way. And that is the human feedback. Basically human comes into picture and gives this feedback back. And that's how you go through the process. This is the most effective way of doing it. But in absence of that, you could use something like Raga's framework and all that, which is basically using another LLM to evaluate. That's what it is.
Got it. Thanks.
Yeah. Okay. And yeah, any more questions? Otherwise, I think you guys also have our emails, so you could reply back to both Prasad and me, and we'll try to also reply back in case you either face issues or you have questions and things like that. We'll be available. We'll try to reply back to you. Or if you face problem in terms of the exercise, some of the things which you are playing around and face any challenges, drop us a mail. I think we should be able to tell you what might be going wrong. Prasad, anything to add from your side?
No, nothing. Nothing from my side.
So just thanks for your patience. That's all.
Yeah, it's a very heavy session. So putting everything into 8 hours and listening and understanding that it's not easy.
Yeah.
No, thank you. It was very, very useful.
Thank you.
Yeah, thanks, Samir and Prasad.
Thank you.
Let's jump
Thanks
forward.
Yeah, I think we thought just jump forward because you have some play sheets, playbooks which you can tweak around and play, so that sometimes you have this hassle, like, where should I start, right? At least if you get a starter code, then you can proceed from that point. And that's what we thought, we'll give you some starter code to play around. Then you can play with it. So that way.
Absolutely. Thank you so much.
Okay. Thank you
Bye-bye.
all.
Thank you.
Yeah, we'll connect again sometime.
Bye-bye.
Okay. Bye-bye.
Okay, everyone. Thank you.
Bye.
Bye-bye.
Bye.
Thank you all.
Thank you. I'll be closing the meeting now. Bye.